is my friend Dr. Vijay Kumar Barik, and he will be delivering today's first session. So I welcome Dr. Barik to start his discussion. Okay, thank you, sir. It was a sound box. Upon checking them, you can have this property. Then the bully best of I am happy to make clear. So that will be sound bully. This person also, sir. It teachers. PGTs.
PGTs. Problems.
Problems have multiple aspects.
Multiple.
Yes.
So, I am Dr. B.K. Barik, and I will talk to you regarding electric potential and capacitance. This is the first session. Here I will tell you some problems, some multiple choice questions, which will be asked in the examination for the students in electric potential and capacitance. First question is, so you all know what is potential and what is capacitance. And there are two charges. Plus 10 coulomb and minus 10 coulomb are placed are placed 10 centimeter apart. Potential at the center of the line joining the two charges. One is 2B and second one is 0, and our one is minus 2B and D is none of the above.
0 is the right answer, sir, I think.
Yes. So potential, you know that that is the amount of work done in bringing a unit positive charge from infinity to that point. So here we can draw a line, and this is the point A, and this is the point B. So here plus 10 coulomb charge is there, minus 10 coulomb charge is there, and distance is between them is 10 centimeter. So at the center of the line means if it is at a distance r, so this is also at a distance r. So potential due to this charge at this point, suppose this is point C, so potential at C due to plus 10 coulomb charge potential, you know, is 1 by 4 pi epsilon 0 Q by RQ is, that is 10 coulomb divided by 4 pi epsilon 0 R. This is the unit is volt. Similarly, due to this charge at this point C, so potential at C due to minus 10 coulomb charge is similar. This is potential is, this is suppose V1, this is your V2, so that is equal to 1 by 4 pi epsilon 0 Q by RQ is here minus 10 coulomb, so this is 1 by 4 pi epsilon 0 10 divided by R, and potential is additive. So at this point C, total potential will be
0.
If you add them, So potential will be V1 plus V2. So that is equal to this 10 by 4 pi epsilon 0 R and minus 4 pi epsilon 0 10 by R. So that is equal to 0. So out of these four questions, four choices, B will be the right answer. Another question is an electron of mass m. Second question is an electron of mass m and charge E is accelerated through a potential difference of V volts. In vacuum. So its final velocity is one is EV by m, B is EV by 2m, C is EV by m root over, D is 2EV by m root over.
2EV by m root over.
When an electron is accelerated means it acquires the kinetic energy, and kinetic energy is half mv square. If m is the mass of electron and v is the velocity, so that is equal to half mv square. And kinetic energy, when the work is done on the charge, so work done is, work done is the potential
E into V. E into V.
Potential is amount of work done for unit positive charge. V is equal to W by Q. And so W is Q into V. If electron is accelerated through a potential difference of V volts, then work done will be electron charge is E, so that is equal to EV. So this because of this work done, the electron acquires kinetic energy. So work done is equal to the kinetic energy. Half mv square is equal to EV. This is the velocity and this is the potential. So the velocity, the final velocity will be v square will be equal to 2EV by m, or v will be equal to root over of 2EV by m. So the answer is B. Then the third question is the possible unit of electric field intensity is Newton by meter. B is Newton Coulomb. C is Joule Coulomb inverse meter inverse. D is Joule Coulomb meter inverse. So you know that electric field intensity, that is the amount of work done in bringing a unit positive charge, then amount the force per unit positive charge. So field intensity is the force experienced on a unit positive charge. That is the electric field intensity. E.
Joule.
And force, you know, the unit of force is Newton. And unit of charge is Coulomb. So this is all in a MK system or SI system. And so if you multiply here meter, then this is becomes Newton meter by Coulomb meter. And Newton meter is your joule work. So joule by Coulomb into meter. So that means C is the correct answer. Joule,
Joule per
Coulomb
yes.
inverse and meter inverse. Then a parallel plate capacitor with air between the plates. Fourth question. A parallel plate capacitor with air between the plates and the capacitance of 2 microfarad. If the capacitor is immersed in a liquid of dielectric constant, if its capacitance is 0.5 microfarad, B is 10 microfarad, C is 5 microfarad, and D is 2 microfarad. You know what is a parallel capacitor? If there are two plates made of the same material and having same thickness, and they are separated by a certain distance. So, and one plate is charged positively. Then this second plate by induction will acquire one face of this second plate will acquire negative charge, and positive charge will repel, and the other face will become positively charged. Because this is a neutral capacity plate, and that is placed near a charge plate, and this is supposed to be placed in air, and when it is earth, so electrons from earth will come and will neutralize the positive charge. This is a this material is electrical neutral. That means that contains equal number of positive and negative charges. So because of the induction, this positive charge will attract the negative charge, and the negative charge will be attracted and be placed, will stay on this face of the capacitor near the plate, and also this positive charge will repel, and the positive charges will be on this face of this second plate. And when it is connected to earth, electrons from earth will flow and will neutralize the positive charge. So that means finally, when this second plate is earth, so positive charge will be, there will be no positive charge. So only negative charge will be there and that will spread over the second plate. So this is the principle of a parallel plate capacitor. And if you have calculated, and so the capacitance of a parallel plate capacitor is equal to epsilon 0 A by B. Epsilon 0 is the permittivity of free space. A is the area of cross section of the plate, and B is the distance of separation between the two plates of the capacitor. So this is when it is placed in a air or in vacuum. But when a dielectric is introduced in between the plates, what is a dielectric? Dielectric is a material which has net charge is 0, but in the presence of electric field, this dielectrics, so they will be, the charges will be displaced, and positive charge like this charges will be like this. So that means the potential by introduction of a dielectric is a, all dielectrics are insulator, and insulator means there will be no flow of current, but some insulators in the presence of electric field there is displacement of charges. Those insulators are called as dielectrics. So when a dielectric is introduced in between the two plates of the capacitor, so this positive negative cancels. So near the first plate some negative charges are developed, and because of the presence of the dielectric, and similarly some positive charges are developed near the second plate of the capacitor. So as a result, this potential between the plates is decreased. So since potential is decreased, capacitance you know is Q by V. So when the potential is decreased because of the presence of a dielectric, the capacitance of the capacitor increases. So this is the main principle of a introduction of a dielectric inside the capacitor. So by introduction of a dielectric, the capacitance of the capacitor is increased. So that means the capacity, suppose this you write as C0, so that is the capacitance of the capacitor in the air or in vacuum. So in the any other
K into epsilon 0 A by D.
So that is hello.
K into epsilon 0 A by D.
Yes, that is equal to
And the
epsilon
answer will be 10 microfarad.
0 epsilon r into A by D, or epsilon r is the relative permittivity, or that is called as the dielectric constant. So that is K epsilon 0
K
A by
into
D,
epsilon 0.
or that is called K into C0. So that this is
5
the
into 2, that is 10 microfarad or?
hello. Oh,
Sir, 10 microfarad.
yes. So that is K is you know is 5. Dielectric constant is 5, and this is as a 2 microfarad. So that is the 10 microfarad. Then fifth question is dielectric, you know, is two types. One is polar dielectric, another is a non-polar dielectric. So question number 5, the electric potential at a point at a distance of meter from a point charge of 0.1 microcoulomb is 450 volts. The electric field at this point will be A is 225 Newton by Coulomb, B is 2.25 Newton by Coulomb, C is 22.5 Newton by Coulomb, and D is none of the above.
Two 25 Newton per coulomb.
Work done for charge. Work done and bringing a unit positive charge from infinity to that point. And work done is force into distance. And that is Q. And force by charge is the electric field. So that is going to be D. So E will be V by D. You know, E is minus the V by dr. Negative sign we have omitted here. dV means V, that is dr is D. V by D is the electric field. So V is, voltage is given is, V is equal to 450 volts. And distance is 2 meters. So that is equal to 450 by 2. So that is equal to 225 Newton by force. So A is the correct answer. Then question number 6. There are 10 units of charge at the center of a circle of a radius 1 meter. The work done in moving 1 unit of charge once around the circle. Is 10 units. B is 100 units. C is 150 units. D is 0.
0.
You know that this is a 10 units of charge is at the center of a circle. This is, suppose this is a circle. So at the center of the circle, there are 10 units of charge. So on the circumference of a circle, since this is center, so it is at a distance r1 meter. So this is a equipotential surface. Potential is, you know, the potential is 1 by 4 pi epsilon 0 q by r. Work done is also, work done per unit charge is also potential. So that is equal to 1 by 4 pi epsilon 0 q by r. R is same everywhere on the circumference of the circle. So potential is same everywhere on the circumference of the circle. So this is a equipotential surface. So if on the equipotential surface work done is 0 because dW is, you know, is q into dV. So since potential is same, change in potential is 0. So work done is 0. So the right answer is B.
सर एठी फोर्स इनटू डिस्प्लेसमेंट करी डिस्प्लेसमेंट 0 तो माने वर्क डन भी 0 हेबो सेठी सेमथि को लेबो ना
Displacement no, this is the potential is change in potential is 0. Empty mother you can also call it this is the force is acting along this direction. The equipotential surface and displacement is here.
Angle is 90
Angle
degrees, so
between
F dot
is
dr
90
equal to
degree.
0.
So
F
work
dot dr
is-
equal to
work
0.
is also 0. But in equipotential surface, force and displacement of the charge is always at 90 degree with each other. Since this is suppose this is a positive charge, you place here positive unit positive charge, force is okay. If this is negative charge, force will be also
It will attract
inward.
90
So
degree.
that means displacement and force they are always at 90 degree with each other. Then question number 7. Two concentric circles spheres of radii capital R and small r have similar charges with equal surface density. Sigma. Surface density is charge per unit, charge per area. That is surface density. What is the electric potential at the common center? One answer is sigma by epsilon 0. Second answer is sigma by epsilon 0 into R, capital R plus R. C is R sigma by epsilon 0. D is sigma by epsilon 0 into R minus R. let some charge hela hoba নহলে মধ্যে মধ্যে হেই পারে suppose there are two concentric circles. Suppose there are it has q charge and this is also q charge. So and this is your capital R and this is a small r. So surface density, equal surface density. These two spheres have equal surface density. Sigma is surface density. Sigma is area of charge of the q. Q is concentrated at the center. The charge distribution is capital Q and it is concentrated at the center. So sigma is q by 4 pi r square. Surface density of charge is charge divided by area. Area of this sphere is 4 pi r square. Similarly, this has also, if charge is q, so that is also 4 pi r square. The two spheres have same surface densities. And potential V1 due to the bigger sphere is equal to 1 by 4 pi epsilon 0 q by r1. Yes, q by capital R. Similarly, potential V2 of the inner sphere, so that is equal to 1 by 4 pi epsilon 0 q by small r. And what is the electric potential at the common center due to these two spheres? So potential is additive. So V is equal to V1 plus V. So if you take, so this is equal to 1 by 4 pi epsilon 0 q by r, then plus 1 by 4 pi epsilon 0 q by small r. Suppose you multiply here r, so this becomes r square. If you multiply r here, that is become r square. And 1 by 4 pi epsilon 0 r q by 4 pi r square is equal to sigma. So that is equal to sigma by epsilon 0 capital R. Q by 4 pi r square. Q by 4 pi r square is your surface density of charge. Q sigma. So that is sigma r by epsilon 0. Similarly, this is also q by 4 pi r square. Q by 4 pi r square is also sigma. Sigma small r by epsilon 0. So if you take common sigma by epsilon 0, that is equal to r plus r. So second is the correct answer. Question number 8. A particle has a charge plus q and particle B has a charge of plus 4q. Each of them of same mass. When the particles are allowed to fall from rest through same potential difference, the ratio of their speeds VA by VB is 1:4, B is 1:2, C is 2:1, D is 4:1. You know that I have told you earlier that when the particle is allowed to fall freely, then the kinetic energy is half mv square. That is falling under the action of the potential, so that is also equal to EB. QB. Charge it is not electron, any other charge is allowed to fall, so that is equal to QB. Or V is equal to 2K is multiplied here, 2QV by M. V square is equal to this, 2QV by M, or V is equal to square root of 2QV by M. So that means particles are allowed to fall from rest to a same potential difference. So for particle A, VA is equal to 2 charges plus Q, so that is Q B by mass are same. And similarly for the second charge, velocity will be charge is 4Q. So this is 4 into 2, 8Q by V by M. So the ratio of VA by VB, VA by VB will be, if you divide this 2QV by M, 2QV by M cancels. So this becomes equal to 1 by 4. VA by VB, so that's VA by VB.
1/2.
This is by 4. So that is equal to
1/2.
1/2. So VA by VB is 1:2. This is the answer.
Sir, sir, ଦୁଇଟା ଯାକ ଚାର୍ଜ ର ଯୋଉ ପାଥ ର ଟ୍ରାଜେକ୍ଟୋରୀ ଟା କଣ ସେମ୍ ରହିବ କି ଅଲଗା ରହିବ?
They are freely falling means they will come and down. Since it has a mass, so they will fall free. Straight.
Same trajectory ରହିବ sir?
Yes. If they are suppose one charge is falling here, another charge is falling here, they will fall straight.
तो चार्ज टू मास रेशियो टा किछि फरक पकेबनी?
Charge? No.
चार्ज टू मास
Falling freely. So it will be, the velocity will be only different depending on the mass, since potential is same. Then question number 9. The electric potential V is given as a function of x. So that is dx is equal to 5x square plus 10x minus 4. The value of electric field at x is equal to 1 meter is minus 20 volt by meter. B is volt. So then minus 23 volt by meter. C is 11 volt by meter. D is 6 volt by meter. You know, this potential is given. Electric field is E is equal to, I have told you, that is negative of the potential gradient is the electric field. Minus dV by R, dV by dr is the electric field. So but here is the dV by R is the distance. So E is equal to minus dV by dx. And D is, you know, is minus dV by dx of 5x square plus 10x minus 4. So that is equal to minus dV by dx of 5x square is 5x square is 2x. So this is minus 10x plus 10.
10x plus 10.
And x is 1.
Minus 20.
So that is equal to minus 10 plus 10. That is minus 20.
Minus 20.
So A is the correct answer. Then another question is, solar. Question number 10. The electric field exist in space around a point on charge plus q.
আর দেখা যাওনি কিছু ব্ল্যাকবোর্ড
হ্যাঁ?
ব্ল্যাকবোর্ড স্যার কিছু দেখা যাওনি
A positive charge plus q, small q, is carried from A to B and from A to C. Where where B and C lies on the circle. Circle with plus q at the center. Work done is first is greater along path SC than along AB. Second choice is greater along path AB than along AC. Same in both the cases. Zero in both the cases. So out of these four possible questions, answers, which will be the correct answer? So I can draw the figure. This is the charge is here is plus q, and this is the point A. A is any point. And here is plus q charge is placed, small q charge is placed, and it is a plus q charge, sorry, a positive charge of plus q is carried from A to B, A to B. And similarly, the charge A from A plus q charge is taken from A to C, and BC lies on the circle with Q at the center. So this B and C lies on the circumference of the circle. So we will calculate what will be the B and C is on the circle at the center. Work done the work. And we know work done is when the charge is taken from this plus q charge is taken from A to B, work done is that is equal to, here the potential is suppose VA and this is the potential is VB. Similarly, potential here is VC. So when the charge moves from plus A to B, so work done will be difference of potential into charge. Q into VB minus VA. Work done is charge into potential, or potential is the work done per unit positive charge. Similarly, when the charge plus Q is taken from A to C, potential is Q into VC minus VA. Since this plus Q charge is at the center of the circle, so this is a equipotential surface. Potential is V is equal to 1 by 4 pi epsilon 0 Q by R. So potential at B is also equal to potential at C. That means VB is equal to VC. So that means WAB is equal to this VB, VC same, this DAB is there. So that means WAB is equal to W of S. So work done is same. Same in both the cases. So this is question now 10. The distance between this question now 11. Plates of a parallel plate capacitor C is double, and area of the section, area of each plate, the section, area of each plate is reduced to half. Its new capacitance will be 2C, C by 2, C by 4, D is 4C. You know, capacitance is the power plate capacitor, the air is there. So C is equal to epsilon 0 A by D. And the new capacitance C1 will be epsilon 0 A1 by D1. Here the C is doubled. Distance is doubled. So distance is doubled means D1 is 2D. Epsilon 0 is remaining same. And the area of each plate is reduced to half. Area is A, so that is reduced to half, A by 2. Or that is equal to epsilon 0 A by D 2 to 4. And epsilon 0 A by D is the original capacitance. So C by 4. So when the area is reduced to half and distance is doubled, so the new capacitance will be 1/4 of the original capacitance. So C is the correct answer. Then nah. And Question number 12. The radius of the sphere having capacity of 0.1 microfarad is 9 kilometer, 0.9 kilometer, C is 8 kilometer, B is 0.8 kilometer. And you know, sphere has the capacity C is equal to 4 pi epsilon 0 r.
0.9
You know, if this is a sphere, so there is a charge, is Q charge is distributed on the surface of the sphere. We assume that the charges are concentrated at the center. So that means if R is the radius of the sphere, so potential on the surface of the sphere is 1 by if it is in air. So this is equal to Q by R. Potential is 1 by 4 pi epsilon 0 Q by R. And capacity of the sphere is C is equal to Q by V.
Q by V.
Yes. So that is called Q divided by Q. So this is 4 pi epsilon 0 R. Q cancels. So this is 4 pi epsilon 0 R. And you know that 1 by 4 pi epsilon 0 is 9 into 10 to the 9. Or 4 pi epsilon 0 will be 1 by R divided by 1. Or 9 into 10 to the 9. This meter. So R will be 9 into 10 to the 9 C.
Into 0.1 micro.
1 microfarad.
0.1 micro.
0.1 microfarad. So this is 10 to the power 9.
Into 10 to the minus
0.1 means 1 by 10. Microfarad 10 to the minus 6 farad. So this is the atomic meter. So this is 10 to the minus 7. It has to 9 2.
9 into 10 to 2.
2 meter, or that is 0.9 kilometer. So B is the correct answer. Question number 13 is the capacitor or capacitance (20 microfarad) is charged to a potential difference of 500 volts. The energy stored in the capacitor is 45 joules, 500 joules, 2.5 joules, and 0.25 joules. Energy stored you know is energy stored is half CV square. C is equal to 20 microfarad. 20 into microfarad 10 to the minus 6 farad into V is equal to 500 square. Thus, okay, 10 into 10 to the minus 6, 10 to the 2, 10 to the 2, 10 to the power 4. 25. 10 to the 4, 10 to the 5, minus 6, 10 to the power minus 1 into 25. So that is equal to 2.5. And the energy is joules. 2.5 joules. So D, C is the correct answer. Okay. Microfarad. This is 5 microfarad. This is 6 microfarad. This is 6 microfarad. So we want to find, this is the rush. This is 2 microfarad. So in this figure, you find the equivalent capacitance. The equivalent capacitance between A and B is 3 microfarad. B is 4 microfarad. C is 5 microfarad. D is 6 microfarad. You can draw the equivalent circuit for which the calculation will be easier for you. Suppose you choose this point as D and this point as C. So you reconstruct this diagram so that the calculation will be very easier for you, because in this figure it is very difficult for me. It will not be so easy to calculate. You will be confused. So first we plot the line A to C. So within AC there is a 2 microfarad capacitor. So we can draw a figure. This is AC. AC, this is your 2 microfarad. Then CB. CB is from C to B, that is 6 microfarad. 6 microfarad. CB. Then B to D D, so that is equal to 6 microfarad. B2 B2D, that is 6 microfarad. This one is covered. Only CD remains. CD, that is 5 microfarad. And AD also remains. AD is 2 microfarad. This one is covered. AC is 2 microfarad. Then CB is 6 microfarad. Then BD is 6 microfarad. BD, then CD is 5 microfarad. CD is 5 microfarad. So that means we have reconstruct this figure in this way. And that becomes very simpler. So you can calculate it, this combined capacitance. Here you see, this is like a Houston's bridge. These are the like resistances. And instead of a galvanometer, there is a capacitor. So when the bridge condition is satisfied, means this by this is it is equal to this by this, or this by this is equal to this by this. So the there will be no current flow in the along this axis CD.
3 microfarad, sir.
So that means since there is no current flow along this capacitor, that will not be charged. So this capacitor is ineffective. As if there is no this capacitor. So now we want to find what is the capacitance at point A and B. So here you see these two capacitors, they are in series. Similarly, these two capacitors are in series. So combined capacitance between A and B, SCB, is equal to capacity is 1 by C1 is equal to 1 by 2 microfarad plus 1 by 6. Are you following? This is a series. So 1 by C1 is equal to 1 by C2 plus 1 by C3. So that is equal to 3 plus 4 by 6 or 2 by 3. So that means along SCAB, so capacity is C1 is equal to 3 by 2 microfarad. Along this. Similarly, here is the 2 and 6. So resultant capacity is also 3 by 2. That means the equivalent diagram is this is a C1 and this is a C2. They are in parallel. This C1 is 3 by 2 and similarly this is equal to 3 by 2 microfarad. And since they are parallel between A and B, so capacitance is combined capacitance is C1 plus C2. So that is equal to C is equal to 3 by 2 plus 3 by 2. So that is equal to 3 microfarad. So first answer is correct. Then question number 15. The radius of a soap bubble whose potential is 16 volt. The new potential is double, sorry. The radius of the soap bubble whose potential is 6 volt is double. The new potential will be new potential of the bubble is 2 volts, 4 volts, 8 volts, 16 volts. Your charge is remaining same. I know C is equal to Q by V or Q is equal to CB. That means that is equal to C1 V1 is equal to C2 V2. And C1, the soap bubble capacity is 4 pi epsilon 0 R1. C2 is 4 pi epsilon 0 R2. Or this is equal to C1 by C2. C1 by C2 is equal to V2 by V1. And C1 is 4 pi epsilon 0 R1, C2 is 4 pi epsilon 0 R2. So that is equal to 4 pi epsilon 0 R1 divided by 4 pi epsilon 0 R2, that is equal to V2 by V1. Or that is 4 pi epsilon 0, 4 pi epsilon 0
सर
cancels.
देखा जाओनी सर
Achha. This is visible. C1 is 4 pi epsilon 0 R1 and C2 is 4 pi epsilon 0 R2. Is it visible?
यस सर यस सर
C1 by C2 is equal to V2 by V1. In place of C1, you write 4 pi epsilon 0 R1 and similarly, this is 4 pi epsilon 0 R1 and C2 is 4 pi epsilon 0 R2. Is it visible? That is equal to V2 by V1. V2 by V1. 4 pi epsilon 0, 4 pi epsilon 0 cancels. So that is equal to R1 by R2 is equal to V2 by V1. Radius is double. Radius is double means this is equal to, this is R and this is 2R. And new potential is V2, V1 is given potential is 16 volts. So R cancels. So this is V2 is equal to 8 volts. So C is the correct answer. Then 16, question number 16. The capacity of capacitor doesn't depend upon charge, voltage, nature of the material, all this. All of this. Capacity depends on charge. C is equal to U by V. Depends on the voltage. But doesn't depend on the nature of the material. But so right answer is C. Okay, so how it goes? দশটা 25 সরি আমি রাখি এটা আউট আছে এটি ঘর সব সরি না के पास है सर there is a 5 minutes break, so after that we will start.
सर हमर केस स्टडी क्वेश्चन पडुची सर केस स्टडी क्वेश्चन
Study माने
केस स्टडी माने किछि गोटे पैराग्राफ दे देथिबो सेइथिरो गोटे क्वेश्चन देथिबो चारटा ऑप्शन देथिबो दे सिलेक्ट
अच्छा
करियो
ओह CBSE
आज्ञा सर
this
आउ
time
गोटे
also no this time you will have in the examination there are only multiple choice questions only.
आज्ञा सर
Recently supply has come that the students will answer only the multiple choice questions because of this COVID.
आउ सर assertion आउ reason सेई टाइप रो क्वेश्चन पडुची
अच्छा अच्छा there will be internal assessment examination and consist of 30 marks only, and there will students have to answer the multiple choice questions. In the main examination, this type of questions will come. So let us start. One or two more questions from this chapter, and then we will go to this alternate current. The effective capacitance between 2 points A and B is this 1 microfarad The answer is this is the multiple choice question. 2 microfarad. B is 4 microfarad. C is 3 microfarad, and D is 0.4 microfarad. Here you see that this 1 microfarad and this 1 microfarad between PQRS, they are in parallel. So this C1 is equal to this plus this 1 plus, they are parallel. So this is 2 microfarad. And so this is equivalent capacitance. This is this one, and then these two becomes 1. This is 1 microfarad, and this is 2 microfarad, and this is 1 microfarad. So they are in series. So that means the combined capacitance is 1 by 1, 1 by C1 plus 1 by C2, and this is 1 by C3. So this is 2 plus 1 plus 2. 5 by 2, or C is equal to 2 by 5. 2 by 5 means 0.4 microfarad. And another question is, a 10 microfarad capacitor is charged to a potential difference of 50 volts and is connected to another uncharged capacitor. In parallel. Now the combined potential difference becomes 20 volts. The capacitance of second capacitor is 15 microfarad. Is 30 microfarad. C is 20 microfarad, and D is 10 microfarad. So 10 micro capacitor has a it charged to a potential difference of 50 volts. So you know CQ is equal to C is equal to Q by B. So charge developed on this capacitor is equal to C into B. Or you can write as C1 B1. The first capacitor you write as C1 and this is the potential. So C1 is given. C1 is 10 microfarad and B1 is 50 volts. So this is equal to 10 microfarad, 10 into 10 to the power minus 6 into 50. So that is equal to 500 microcoulomb. And C1 and C2 they are connected in parallel. So the resultant capacity is equal to C1 plus C2. And Q, the total capacity, a charge is equal to charge developed in the first capacitor plus charge developed in the second capacitor. Or that is equal to Q1 is equal to C1 B1 plus C2 B2. This is a common potential, so this is V1 is equal to V2. And that is equal to Q is equal to Q is 500 microcoulomb. That is equal to common potential. You can B is if you take it C1 plus C2 is equal to 500. Or B is C1 plus C2 is C1 plus C2 is equal to 500 by voltage is
20.
20. So that is equal to 25. 25. C1 is capacitor has capacity 10 microfarad. So 10 plus C2 is equal to 25. C2 is equal to 50. So correct answer is 15 microfarad. Another question. If the dielectric slabs of 4 into 10 to the power 5 meter pitch is introduced between the plates of parallel plate capacitor the distance between the plates is to be increased by 3.5 into 10 to the 5 meter to resume the capacity to original value. Resume the capacity to original value. Then dielectric constant of the material is A6, B is 8, C is 12, D is 20. You know, if dielectric of thickness T is introduced between the plates of a parallel plate capacitor, then capacitance is increased, so that becomes equal to, this expression is there in your book. So epsilon A divided D minus T into 1 minus 1. When the dielectric, this is the capacitor, when the dielectric of thickness T is introduced, this distance is D, and this dielectric of thickness T is introduced between the two plates of the capacitor, then capacitance become epsilon 0 A by D minus something. So because of this term, the capacity is increased. To restore the original capacity is epsilon 0 A by D. The distance between the plate is to be increased by a to resume the capacity to original value. So that means by introduction of this dielectric, your capacity is becoming this. But to attain the capacity epsilon 0 A by D, so this term must be equal to, suppose thickness has to be increased. This, so that means T 1 minus K, thickness is to be increased between the two plates, so that if this is increased, then this plus this one becomes equal to 0. So this capacity becomes epsilon 0 A by D. T is given X is given 3.5 into 10 to the power minus 5, and thickness of the plate is T is given, that is 4 into 10 to the power 5. So that means 4 into 10 to the power minus 5 into 1 minus K is the dielectric constant, is equal to X, 3.5 into 10 to the power. Minus 5, 10 to the minus 5 cancels. So this is 3.5 divided by 4. So that is equal to 1 minus 1 by K is equal to 4 by 3.5. Mm-hmm. 3.5. 3.5 by 4 or 35 by 30 or 1 by k is equal to 1 minus 35 by 40. 40 minus 5 by 40, or that is 1 by 8, or k is equal to 8. So correct answer is B. So this is all regarding multiple choice questions in potential and capacitance. Then we will talk regarding the alternative current. You know what is the difference between alternate current and DC current? DC current is the with time, the potential is the current is same. Reasoning really nice. Multiple choice questions.
Multiple sir reasoning. Multiple choice sir reasoning. Reasoning you are telling me why out of why this is.
And the answer so you have to give me reason.
Multiple sir reasoning.
नहीं तो से मामू से वो कितना बच्चा थी कि पहले ना हमको आश्चर्य था इंस्ट्रक्शन only मैंने multiple
choice only reasoning चाहिए आपने कौन सा है why out of this one why this one is
मैंने with the fundamental
yes
that is any questions will come be answered.
Why this is the answer that you are telling me
that
that is the reason reasoning
So the current which changes its magnitude and with time and direction reverses periodically in direction. So that is called AC current. And for AC current, we write as I is equal to current is I0 sin omega t. I0 is called as the peak value of the current. Omega is the angular frequency. Omega is 2 pi by t, or that is 2 pi 1 by time period is the frequency. So I is equal to I0 sin omega t, or I is equal to I0 cos omega t. So that represents a alternating current. And if you plot the graph between time and current, so current will be like this. Because at t is equal to 0, I is equal to 0, it starts at 0, and similar t by 4 fourth of the time period, it is the maximum value I0, and at t by 2, so it becomes 0, t by 4, it is reverses its direction, and at t, this is 0. So current is changing with respect to time. And an average current over a whole cycle is 0, because during a half cycle, if it is positive, during the next half cycle, this is negative. So during the whole cycle, so the average value of the current is 0. But since this current one passes through a resistance, it is heated, so it has the effective value that we call it as RMS value, IRMS. And IRMS is the peak value divided by root. That you have also known, because if you calculate this, I just tell you that when the average value is 0 and the effective RMS value of current is the steady current, which produces same heat when flows through a given resistance for a given time as produced by alternating current going to the same resistance and same time. And the heat produced is ds, suppose I write as according to joules of electric heating, this is I square R dt. And I is I0 sin omega t, so this is I0 square sin square omega t R dt. And total heat produced will be integral of this, and this is equal to I0 square is common, constant. This is peak value of the current, so R is also common. This whole cycle is 0 to t, and this is sin square omega t dt. So if you calculate, so this will be I0 square. This is 0 to t, so this is I0 square r t by 2. And if I is the RMS value is I RMS read. So that is heat produced will be I square RMS R T. So that is equal to I square I RMS square R T. Or I RMS is equal to I RMS square is equal to I0 square TTR cancels I0 square by 2, or I RMS will be I0 square I0 by root. Similarly, RMS value of the alternating voltage E, if you write as E0, similarly sin omega t or cos omega. So similarly, E RMS also will be root mean square value is E0 by root. This is the peak value of E0 is called as the peak value of the voltage. 1 by root 2 is 0.707. So question number 1. A voltage E is equal to 60 sin 40 pi t is applied across a 20 ohm resistor. What will be on what will an SC ammeter in series with the resistance read. Answer is 3 ampere, 2.12 ampere. C is 1 by 3 ampere, and D is 3.12. We write E as equal to E0. This is alternating current, so this is E0 sin omega t, or that is equal to 60 sin 120 pi t. So if you compare these two, E0, the peak value of the voltage is 60, and omega is 120 pi. And resistance, I0, SC ammeter will read what? SC ammeter, alternating current ammeter will read only the RMS value. If you connect it to the DC ammeter, so DC ammeter will give you the 0 volt in the current, because average value of current is 0. If you use a SC ammeter, so that will read only the RMS value. So E0 is 60. So our I0, what will be SC ammeter? SC ammeter will read IRMS. It is asked IRMS value. So that is I0 by root 2. I0 is E0 by R into root 2. And E0 is 16. R is given, resistance is given 20 ohm. The volts. So that is equal to 60 divided by 20 root 2. 3 by root 2. ampere. Sorry. Root 2. 3 by root 2. Root 2 value is 1.414. So 3 by 1.414. So that will be 2.12 ampere. So result is 2.12.
Setting up a
The effective value of alternative current is 5 ampere. The current passes through ohm resistor. The maximum potential difference across the resistor is 60 volts, 60 by 2 volts, 2 volts. C 60 to 2 volts and D 12 to 2 volts. And peak value of current, it is given the effective value of alternating current is this is the RMS value. So this is IRMS is equal to 5 ampere. So peak value of current IRMS is equal to I0 peak value of current by root 2. Peak value is this is the peak value. This is I0. So I0 is IRMS into root 2. IRMS is 5. So this is I0 is 5 root 2 ampere. Maximum potential difference, maximum PD is equal to E0, that is I0 into R. Maximum there is potential difference. This is not acting the RMS value of PD. So this is equal to 5 root 2 into resistance is 12 ohm. So this is 60 root 2 volts. So correct answer is A. So let us stop.
Thank you, sir.
Microphone. Sanatana microphone. Jawali. Jawali then it red tab and red tab green. Green. Hello. Hello. Well, PGTs and physics. Now we move for the second session. Today's second session, and the resource person is Madam Dr. Arundhati Misra. She was the head of the Department of Physics and very senior reader, and who has just retired around 1.5 years back, 1 year back around. And I don't want to become a bar between her and you people. So now I request Dr. Misra to start her session. Dr. Misra, please.
Thank you, Subhash sir. Good morning to one and all. We are here to share some objective views regarding some texts like, can you hear me all? Can you all hear me?
Yes, ma'am. Yes,
Thank
ma'am.
you.
Yes, ma'am.
Thank you. Now will be shortly following some applications, electric fields and Gauss law. We'll be doing some multiple choice questions. But before that, I would like all teachers would like to text something to the students. Before that, prior to all this objective, you must relate to some text like Coulomb's law. I'll be hurriedly going through these two slides. The force between two charges is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. And you know, there you must explain what is 1/4 pi epsilon naught, that is 9 × 10⁹ Newton meter square per Coulomb square. And E0 is the permittivity of free space. Okay. Then comes the electric field concept, where you must tell them that why only field, why only electric field? Any field is a modified space. Since you are talking of an electric field, it is a space modified due to the presence of charges. Or the ordinary definition is the field due to a point charge at a point P is numerically equal to the force exerted on a test positive charge placed at that point. So E is Q/4 pi epsilon naught r square ER unit vector, where ER is the unit vector in the direction of increasing R. Then comes the Gauss law, where you have to tell the surface integral. Okay, the electric field, the total normal component of the electrical induction over a closed surface is 1/E0 times the total charge enclosed. What we have written here is the flux of the electric field across a closed surface is equal to the total charge enclosed. Then comes the differential form of Gauss law that you must throw light on. That is del dot E is 1/E0 times rho, where rho is the volume charge density. Now, while explaining this, you must tell them that the determining, that means the Gauss law is used for convenience for determining the flux and for the charge distributions. And when it is while determining the charge distribution, we make, just let me put it, just 1 minute. It should be symmetric. So no charge distribution can violate Gauss law, because the electric field in the bulk conductor is always 0. And from 1 and 2, we conclude that the free charges cannot reside in the bulk conductor. Then comes the potential. The electrostatic potential is actually the work done in carrying a unit positive test charge. Why it's going like this? Sorry, children. Yes. So I am in the second slide. So electrostatic potential due to a point charge Q at a point P is equal to the work done in bringing a unit test positive charge from infinity to a point P, such that the test charge is never accelerated. It remains the same in a quasi-static equilibrium. So we know that V is from infinity to a point R with F dot dr, where F is minus E. If you have a charge Q at that point, it will be minus Q E dot R dr. Okay. So next, let's go to another small text that you must tell them that if you have an infinitely long conductor, a positively charged plate, then you should just 1 minute, children. Where is my pointer? My pointer. Just 1 minute. I must bring my pointer. Here, there's an infinite charge conductor. You will have a point for P where it is at a distance R from this charge plate. So how will you find out the electric field at this point? You have to make a closed surface, a Gaussian surface. That means you should take a distance R. That means this is the radius. So you have two areas. This is one area, and this is the length L. So the curved surface area is 2 pi RL. Pi r square is the area of this space, and pi r square is the area of this space. Now look at this. The electric field is vertically downward, and you have the area vector also parallel to the electric field. Sorry. And then you have the Z, that means the cos component here, E dot dA. The cos component here you will have, this is in this case, this is electric field here, it is along the radius vector. Here, this is the area vector. So this is 90 along this area, and here it is 90 along this area. So this will see, you will see that the flux is, this is phi 1, phi 2, which are EDA cos 90, EDA cos 90. That means there will be no, the flux coming out will be zero in from these two surfaces. Only flux which might come from here is this, the curved area. And what is the curved area here? EDA, E is constant, E is electric lines of force, E into integral of dA, which gives you 2 pi RL. So 2 pi RL into E is the total flux. But total flux, in case of this line charge, that means you have lambda is the charge density. What is the charge density? Charge per unit length. If the total charge is capital Q, the total length of the conductor L, infinite means doesn't mean it's very, very long. Yes, it is very long compared to this distance R. So Q inside divided by L. So lambda is cube. This is lambda L is equal to Q. So lambda L by E naught is equal to EDA. So you have LL cancel, and then lambda by E0, you bring 2 pi R here. So you get electric field at that particular point, which is the distance R is lambda by 2 pi E0 R. Please remember this slide, E proportional to 1 by R. That means electric field for a line charge conductor, infinitely charged or a charged wire, is going inversely to R. Okay, when R increases, E decreases in this ratio. Next. Here again, another one. Suppose you have a infinitely plane sheet of charge. Positively charged. And I think of an area of this amount. This area, and this area. Why I have taken this? Constructed this Gaussian surface. I have taken a point P. Initially, when I drew it, I simply had the sheet, which was positively charged plate, which is infinite means doesn't mean it's very large compared to the distance of this point P from this sheet. Okay, so this is at this point X from the sheet. We have to calculate the field at the point P due to this distance X from this infinite sheet. Okay, now you make a Gaussian surface. That is, you make a closed area here, complete a cylinder of length L and area A. Okay, this is a small area dA, which is at an angle 0 to the electric field lines of force. Here it is 0 to the electric lines of force, and the curved area is at a 90 degree to the lines of force. Now, since this is a surface, you have drawn a small dA surface. Let us say that sigma is the surface charge density, the charge per unit area. The charge per unit area, that means total charge enclosed for the sheet is Q. A is the total, A is the area of the sheet, then Q by A is the sigma. Okay, so sigma is Q by A. Now, keeping this in mind, let us go to the Gauss law. What is Gauss law? The total flux that is equal to EDA by 1 by E0 times Q inside is the phi total. So phi total is 1 by E0 times Q inside. So phi total is flux phi 1, flux phi 2, and flux phi 3. So phi 1 and phi 2 is EDA cos 0, EDA cos 0, EA, EA, and phi 3 is this one. There the area vector is 90 degree to this electric lines of force. The area vector is 90 degree to the lines of force. So what happens? Cos 90 is 0. So the no flux comes out from this small shaded one. Only that means from the curved area ones. Okay, that means this is small area I have taken. The entire curved area doesn't contribute. So only two things that they contribute is this one, this area, and this one. So the flux phi1 plus phi2, that is cos 0, EDA cos 0, that is EA into EA is equal to 1 by E0 times Q inside. What is your Q inside? This is sigma by, this is Q inside by E0 is twice EA, because this is EA, twice EA. So 1 by 2. So A cancels because Q is equal to sigma A. I just defined my sigma. Sigma into A is Q. So sigma A by E naught is 2EA. So sigma by E0 is 2E. Why am I telling you all this when I'm supposed to talk about objective? Simply because I'll be slightly going off faster if I tell you that the electric field is sigma by 2E0 here. For every positive charge plate or a negative charge, this is sigma by 2 epsilon. Next. Now here, I am coming to the problems. Suppose I have three charges, Q, plus Q, and minus Q. They are placed on the vertices of an equilateral triangle of side L. So this is an equilateral triangle of side L. There is a plus Q here, plus small q here, and a plus small q here. Now, these are all distances between the charges are same. Now, if the condition is given, the net electrostatic energy of the system is 0, what is the value of Q? You have multiple choice answers. Okay, questions. Okay. Now, U is 0. What is the formula for the electrostatic energy? 1 by 4 pi epsilon into product of the charges by distance between them, not L square. Children, I have just struck off the 2. So it is only L to the power 1. Okay. So capital Q, and then small q. This is the force between these two. This is energy between these two charges. Q by L. The energy between this and this is Q by L. Again, this Q by L. So sum of this is 0 given to you. So take out this common Q by 4 pi 0 and L is common. Simply you get 2Q plus Q given to be equal to 0. What do you get? You get capital Q is minus Q by 2. So the option number A. Next, the electric field between two parallel planes are and oppositely charged plates. You have given two parallel plates which are oppositely charged like capacitors. Okay, one is positively charged P, one is negatively charged Q given to you. Now you have to find out the total value of the field at this point A. So electric field between two parallel plates and opposite plate A. So you have to find out the field between these two plates. What is the field in between these two plates? Now take a point A. If the point A is taken, now look at this is positive plate. Where will the flux go? It will go away along the direction AX. Think positive, due to the positive charge, if you think of a point A here, the flux will go outward. And for the negative plate, the flux will be going inward. So what will happen? The electric field E1 due to P, that is at point A, is sigma by 2 is 0. I just calculated and showed it to you, is towards AX. And then sigma by 2 is 0 towards AX dash for the electric field due to the point Q, due to the conductor Q. So this is towards AX dash, one is towards AX dash, and one is towards AX. And these are like infinite sheets, plain sheets of charges, so you can say that. So it will sigma by 2 is 0 plus sigma by minus 2 is 0. That means it is a minus sign because it is going inward. Then the net flux, this will be equal to 0. So you can say the field due to E1 minus E2 is sigma by 2 is 0. Plus of minus sigma by 2 is 0. This gives you 0. So the answer is option C. The next, in the given figure, the distance of point P where the electric field is 0. This is a very simple question. You have P and Q, and the figure, you have a 20 coulomb sitting at point P and a 40 coulomb sitting at Q. The distance between them is 80. Okay. The distance between them is 80 centimeter. Now find out a point where the field due to these two 20 and 40 coulomb is 0. Let us choose a point which is at a distance x from P. We have to find out the value of x of 20 centimeter, 10 cm, 33 cm, none of the above. So you have to choose from this. Okay, so take this red point which is at a distance x from P. Now the field due to this point 20 coulomb will go away from P. That will be EP will be directed away from P. And the field due to this 40 coulomb will be EQ, which will be going away from Q. So EP and EQ are equal in magnitude and they cancel each other because the field has to be 0. So what happens? You will have the formula EP. What is the field due to at point P? Field due to the charge 20 coulomb at P. that field due to coulomb 20 coulomb is 1 by 4 pi epsilon 20 by x square. And field due to the 40 coulomb is 1 by 4 pi E0 40 into 80 minus x square. Now simply you get 20 and 40 cancels. This is 2 simple maths. 1 by x square. You take the under root, that is 1 by x is equal to root 2 by 80 minus x. So if you solve 80 minus x is root 2x, 1 plus root 2x gives you 80, and that is 80, and root 2 is 1.414. So 2.414 by 80, that means you'll get 33, absolutely 32.9. So it will be answer is 33 cm. So do you get that? So x is at a distance 33 cm, but the electric field due to these two charges is 0. The next, which of the following results in free space are expressed in units of coulomb? What is this question? You are given 4 formulas. You have to find out which formula has unit of charge. That means only Q, not 1 by E0. And we know Gauss law. Gauss law is E dot ds is 1 by E0 times Q. Now, Q, if you define in terms of volume density of charge, Q is rho dV. So if I write E dot ds from Gauss law is Q, Q instead of Q, I write 1 by E0 rho dV. Okay, I keep it over here. What is rho dV? Which is Q. Now bring this E0 towards this capital E. E0 is the displacement current. Displacement current D dot ds is Q. So it is having the unit of coulomb. Now you can also guess this way. First option is out of question because it's a line integral. The second one is also, a third one is also out of question, it's a line integral. The choice is between B and D. Now E dot ds will not have coulomb as the unit because 1 by E0 times Q here. So you can just guess that it must be D. But this is how I explain it to you, that E0 E dot ds, that is D dot ds gives you Q. Q is in coulomb. So the option D is correct. And please note that the displacement current, when you talk to the child about the displacement current, you must tell them that the conduction current is the direct flow of current that is due to the flow of electron, and the displacement current is due to the current due to the in a capacitor, which is due to the varying electric field. Next, you have again a very simple question. I'm going through the simpler ones faster. Please excuse me for going fast in this. 2-point charges Q1 and Q2 are 3 meter apart. 2-point charges Q1 and Q2 are 3 meter apart. Their combined charge is 20 coulomb. That means Q1 plus Q2 given to be 20 coulomb. Q1 and plus Q2 is given to be 20 coulomb. Now, if one repels the other with a force of 0.075 Newton, what are the two charges? They have asked you the value of Q1, Q2. Sum of this Q1 plus Q2 is 20. One of them will be, if Q1, then Q2 is 20 minus Q1. It has to be in terms of Q1 now. Now you take it, very simple. You take a force. What is the force between them? 0.075 Newton equal to 1 by 4 pi E0 is 9 to 10 to the power 9 Newton meter square coulomb per coulomb by Q1 into Q2 by 3 meter, because the distance is 3 meter between them. So 3 meter ka square hai. This 9 and 9 cancels. So you have 10 to the power 9 here. Q1 into Q2 is Q1 into 20 minus Q1. 75 into 10 to the minus 12, because this 10 to the power 9 comes to this 0.0 10 to the minus 3. So this becomes 10 to the minus 12. That becomes micro coulomb square, because each micro coulomb is 10 to the minus 6. So 75 into 10 to the minus 6 into 10 minus 6. So you get 75 micro coulomb square. Now this is a quadratic equation, which is Q1, that is minus 20 Q1 into Q1 square, that is Q1 square minus 20 Q1 plus 75 is equal to 0. That means you have brought this part to this side, to the plus 75 side. So you bring, so it is Q minus Q1 square becomes positive. So Q1 square minus 20 Q1 plus 75 equal to 0. Now you just spread the middle term, split it, minus 15 Q1 minus 5 Q1, you get Q1 as 15 or 5. So either of them, so you'll have either 15 and 5 are the options for them. Is that clear? Now this is also very simple one. This is about a superposition principle. If the individual forces acting on a given charge due to the presence of 5 charges are represented by the sides of a closed pentagon, what will be the resultant force on the test charge? There are two options. One is 0 and one, the A is sum of those forces. Now solution. Using principle of superposition, you have due to F1 is due to the first charge, F2 is the force due to the second charge alone, and so on and so forth. So what are the sum of those forces? This will be only the sum of F1, F2, F3, F4, and F5. But here you have these vectors. They are represented by a closed figure, and that too as sides of a closed pentagon. And we all know that in a closed figure, the resultant of the vectors form a closed geometrical figure. The resultant of these vectors is always 0. So the option B is correct. Now, you have two positive point charges, 10 microcoulomb and 5 microcoulomb. They are 10 centimeter apart. The work done, find the work done. Work done means energy, think of it. The work done in bringing them to a distance 5 centimeter closer. What is this? You have two charges. Initially, they have, what is the distance between them? 10. Now they have to come to a 5 centimeter distance. There has to be work done against it. So the final energy minus initial energy will be your energy or the work done in bringing them to a distance of 5 centimeter. So this is 5 centimeter. From 10 to 5 they have brought. It has been brought. So Ui initial, what was the initial energy? 1 by 4 pi is 0, which is 9 to 10 to the power 9 into the product of the two charges. What are the two charges? They have 5 microcoulomb and 10 microcoulomb. So 10 into 10 to the power minus 6, 5 into 10 to the power minus 6. By the distance between them is in meters, 10 into 10 to the power minus 2. So this is 9 to the 10 to the power 9, which is 1 by 4 pi is 0 is 9 to 10 to the power 9. You get 10 to the power minus 12 and 10 into 5 by 10 into 10 minus 2. Similarly, you get the final energy. The distance is, instead of 10, it is 5 here. Rest of them is all same. 1 by 5, 5, 5, 4, 5 is 0. Instead of that, you keep 9 into 10 to the power 9. Then you have again a 10 into 5 and 10 to the minus 12 because it is coming from microcoulomb, 10 to the minus 6 minus 6. So rest of it is same except the down below you have 10 to the minus 2 and distance 5. Here you have 10 to the minus 2 and distance 10 in Ui. And what is the work done? It is final minus initial. Final minus initial. So you will have 9 into 10 to the 9, 9 into 10 to the 9 outside. The charge 10 into 5 will be there. The 10 into 5 will be outside and 10 to the minus 12 is also outside. And this 10 minus 2. These are all common things taken out, except within the bracket you have 1 by 5 minus 1 by 10. Just solve it. Just solve it yourself. You'll see that this gives you 4.5 joules. 4.5 joules. Option B is correct. Option, because this 10 to the 9 here, 10 to the 12 and 12, these are all getting cancelled. You are simply getting 45 by 10. So you are getting 4.5 joules. This 5 and 5 also cancel. So you have only 45 by 10, so 4.5 joules. Option B is correct. Now this is again, a hollow sphere of charge does not produce an electric field at any point beyond 2 meters, beyond 10 meters, interior point, outer point. How will you take the option? I have already marked it as interior point. That's the correct answer. But you must speak it out. What is the explanation for it? You know that a hollow sphere, the field only resides at the outer surface, but the potential is all throughout. The potential is from here to here. The electric field, even from the surface, it will go on decreasing as you go, increase the distance from the surface to the outer distance. But what is the option given to you? Point beyond 2 meters, point beyond 10 meters does not produce, there is still field. But in the interior point, it has no field. Electric field is 0 inside, so it is interior point. It has still field outside, okay? It will be 0 somewhere very large distance. So you cannot say a point beyond 2 meters and 10 meters, okay? So interior point is the correct answer. Now, this is a very good question. Now, all of you must explain about the flux first to the children. Find the flux of E through a cube of side A. You have been given A. This a cube has 6 surfaces. This is a surface A, B, C, D. You have a surface P, Q, R, G, R, S, P, Q, R, S. Okay. These are 2 pairs which are in red, marked in red. Okay. Now, what is the condition given to you in the figure? E is E0 XI. That means this is the E is increasing in the X direction. As you go on changing X, E is going on changing. Okay. Now at point D, E will be due to the distance A. At point PQ, that is RS PQ, it will be due to 2A. Okay. So first calculate the flux through this face ABCD. ABCD. Why am I calculating ABCD? Why not the other 4 phases? You know, the other 2 pairs of forces, incoming and outgoing, will be simply cancelling with each other.
Perpendicular.
The cube, yes, they are the symmetrical distribution, so they will be going, this will be 0 for them. So I'll be only taking only these 2 pair of faces. Do you get that? So ABCD and PQRS, I'm taking these opposite faces. The rest of it I'm not bothered because it is 0. Now I'm calculating the flux from the point ABCD. How it will be? EDA, that will be EA. EDA, DA ka integration A hoga. So E from ABCD, E is at E0x. EX, that means E0 into X kitna hai idhar se? A. So E0 into A. And what is the area here? A square. So what does this give in? E0 A cube. I have put already a minus sign because it's an incoming flux. Okay. You need not put it, but it is incoming flux. Now let us come to PQRS. What is the flux through PQRS? It will be again, it will be E0 2A into A square. Isn't it? Because the distance is 2A from the origin. So instead of A, the middle one, it will be changed to 2A for a PQRS. Just see this. This is for PQRS, it will be E0 2A A square. So you get this is the outward flux, it is positive, the inward flux is negative, so add them. So the net flux is what is? E0 A cube. So option B is correct. Just see the option, E0, option C. Have I written option C? No, it has to be C. Please change it E0 A cube, okay? E0, yes, option B, it should be option B, not C. Please correct it, it is option B. Option B, I have written it here, okay? Now, consider the cylinder of radius R and length L. Did you follow that, students? Did you follow the previous question? Please correct it.
Yes,
It will not have this
yes,
one.
ma'am.
Okay, thank you so much. A cylinder of radius R and a length L is placed in a uniform electric field. Okay, a cylinder of radius R, length L, is placed in a uniform electric field in such a way that the axis is parallel to the field. The axis is parallel to the field. This is important. Now you have to find out the flux of the field through the cylindrical surface. I have already given you the text in the previous slides. Okay. Now let me explain this. You have this part. Yeah, yes. These are the electric uniform lines. You know that this here, this is the incoming. This is the incoming flux. This is the outgoing flux. The net flux will be E0A cos 0, E0A cos 0. One is positive. The outward is positive. Phi 2 is positive. Phi 1 is negative. That gives you 0. Now phi total is phi 1 plus phi 2 plus phi 3. So what is phi 3 now? Again, this part is the angle is the area vector is 90. So you get E0A cos 90. So the entire answer is 0. Here, what am I highlighting, students? You know, this part, sorry, teachers. Here, this part, you must tell them that this is important. What I have put it in bold, that whenever that you have a closed surface, if it is placed inside a uniform field, the total flux is 0, provided there is no charge inside the surface. This condition has to be there. The total flux is 0, provided there is no charge inside the surface. Go to the next one. This is another easy question. We have already done the equilateral triangle. This is a right angle triangle. Q plus Q and a plus Q, they are all in the vertices of a right triangle. And find out the net electrostatic energy is 0. I have just told you the formula for electrostatic energy. What is the energy? 1 by 4 pi E0 into product of the charges by distance between them. But here, this distance will be A by root 2. I think this distance is A, this distance is A, and what will be this Q minus Q ka distance? A root 2.
Root 2.
Yes. So if you please solve it, you will get the option B. I'm not calculating, I'm leaving it to you. Okay? This is minus 2Q, 2 plus root 2. Okay, this is also a very simple question. An electron is moving towards x-axis. An electric field is going along y direction. The path of the electron is circular, elliptical, parabola, none of this. Electron is moving towards x-axis and it is moving inside. An electric field is along the y direction. So what happens to the electron when it is inside? Suppose you have a charge plate, that is plus and minus field. So here the electron was free. This electron was simply going crest. It was going in the straight line. But as soon as it enters the plate, it will bend. It will go a parabolic. And it will experience a force. What will be that force which will make it parabolic? EE, minus EE. Okay. So the answer is parabola. Now the electric potential. Here it is, you know, you must, when I told you about the potential there in the from R to infinity F dot dr minus E dot dr, there I should have told you that you must tell the students that it is also the negative gradient. I mean, minus dv by dx is E. Okay, electric field is minus dv by dx, del dot V. Okay, so electric potential at any point O x y, O is a point which has coordinate x y z, all in meters, in space is given as V equal to 4x square volt. The electric field at the point 1 meter, 0 and 2 meter in volt per meter is, how you calculate? It is given x, y, z, O. So V is 4x square. Now it is only, it doesn't have y component, doesn't have z component. What is the electric field is asked? Electric field is minus dv by dx I, minus dv by dy j, minus dv by dz k. That is minus del dot V. You don't have y and z to put 0 and 2 meters coordinates. Simply you have minus dv by dx. So you have E is this. So just take out dv by dx. This is minus 8x. At x equal to 1 meter, you'll get minus 8. So the answer will be 8 along negative x-axis. So just other, these two are wrong. It cannot be positive axis. This will be negative x-axis. Okay. Is that clear?
Yes.
The next one is again a very simple one. An alpha particle is accelerated through a potential difference of 10 to the power 6 volt. Its kinetic energy will be. Now kinetic energy is charge into potential. And what is the charge? Alpha particle twice of electronic charge 2e, and it is 10 to the power 6 volt here. It is this QV in joules. Now if you want to make it electron volt, because these are on in MEVs, if you make it electron volt divided by an electron 1.6 joules mein nahi karna hai, so divided by E. So E gets cancelled. You get 2 into 10 to the 6 EV, that is 2. That will be 2 MeV. 10 to the 6, 1 MeV is 10 to the 6. So it will be 2 MeV. Is that clear? Okay. An electron enters between two horizontal plates separated by 2 millimeter, having a potential difference of 1000 volts. So here you are having an electron entering a potential difference of 1000 volts, and the separation of plates is 2 into 10 to the minus 3. Okay. So you have 2 into 10 to the minus 3 is the separation D, V is the 1000 volt. And what is the force is E into E. What is E? The expression of dV by D, or V by distance between the two electrodes or the two plates. So V is 1000 volts, V is 2 into 10 to the minus 3. And what is your E? Charge is 1.6 10 to the minus 19. Just 1.6 10 to the minus 19. And you have a 2 here. So you will have a 0.8, it will be 8. So 0.8 into 10 to the minus 13. Because this is minus 19, this is minus 16, niche bhi 3 hai, so it will become minus 13. That is 8 into 10 to the minus 14. 0.8 into 10 to the minus 13 becomes 8 into 10 to the minus 14 volt. So the answer is 8 into 10 to the minus 14. Okay, you'll have the separated by this, having a potential difference, the force. So this will be Newton. 8 into 10, sorry, it will be Newton. I'm calculating this force. Okay, F, we are calculating force. This is Newton. So
Okay.
8 into 10 to the minus 14 Newton. You have taken the formula E. E is V by D. You put the charge. This is the charge multiplied by potential difference by the distance between the plates. And this gives you 8 into 10 to the minus 14 Newton. So the option B is correct. Next, again, the same type of a problem where you have a potential of this kind, 5x square plus 10x minus 9. Just take the differentiation with respect to x, because it is only given, find the field at x equal to 1. So minus dv by dx. So take it minus 10x, x equal to 1. It will give you 10.
Okay.
Okay. So, and
Okay,
then,
okay.
and you have a, here x, another 10x is there, right? So this is x equal to 1. So you will have minus 10, you will have 20. Okay. Because this is negative gradient. So it will be minus 20 volt per meter. Did you get the sign? Is it minus 20 or not?
Yes, ma'am. It will.
Okay. Now, these are also simple problems. Suppose someone asks you, what is the flux from a semi-cylinder? It is as good as asking you consider a point P, which is at a distance R from a infinite charged wire, or a plane conductor, or a charged wire. Yes, it is simply, if you have, yes, it will be simply half of it, Q by 2 is 0. So for a semi-cylinder, Q by 2 is 0. And for a hemisphere, it will be again Q by 2 is 0, isn't it? For a, because you have to make a Gaussian surface, which will give you Q by epsilon naught, and a hemisphere will be half of Q epsilon naught. Okay, 1 by E0 cube. Similarly, for a cylinder, if you total make a Gaussian surface, this is your semi-cylinder. Suppose you have been given this part that it is at a distance L by 2. So you make a total length. So you will have, the length doesn't come into the picture. The total charge enclosed is Q. And what is the electrical flux? E dot ds, it is 1 by E0 times Q. But this is only half the area of the cylinder. So semi-cylinder will be half of Q by E0. So answer is half of Q by E0. Now suppose a question of this kind is given to you. Instead of telling a Q ka center, suppose a square plate is given of side A, dimension A. Now you have a point P, which is at a distance A by 2. A charge situated at a distance A by 2. This is a charge Q sitting at a distance A by 2 from A. Find the flux. How do you find out? It is Q. Now this Q is symmetric to all the surfaces, is it? Now, what is the total charge enclosed here? 1 by E0 times Q. If you make a complete this figure, a cube, then what happens? You have 6 faces. Now, from each face, how much flux will come out? 1 by 6th of that Q by E0, isn't it? So you will get, so you'll get Q 1 by 6th of that. Now, where is this one? This part. I was talking about this. This will be 1/6 of that. If I asked you, this will be 1/6 of E0. We'll have another problem like this at a distance A by 2. This is find the flux from a distance A by 2. This will be 1 by 6 times. So we'll solve it a little later. Now, say this. If Q1, Q2, Q3 are the point charges located as shown, S is a spherical surface, Gaussian surface of radius r. Which of the following is true according to Gauss law? The surface integral, all the 3 fields dot dA is equal to Q1 plus Q2 plus Q3 by 2 E0. Surface integral E1, E2, E3 dot dA equal to sum of the 3 charges by E0. Flux phi is this much. And the third one is E1 plus E2 plus E3 dot dA equal to all the 4 charges, the charge even from outside by E0. Then none of the above. Which one is correct? According to Gauss law definition, it is directly. Which one will be correct? It will be the total charge enclosed. So it will be the option B. Now come to this. A point charge Q is positioned at the center of the base of a square pyramid. Okay. As shown. The flux through one of the 4 identical upper surface of the pyramid is Q by 16 E0, Q by 8 E0, Q by 4 E0, none of the above. How will you go by this? You have a pyramid, you have a square, you make a pyramid, it has 4 faces. Now, complete a closed figure because you can make another pyramid. So it will be the total charge. This is the flux phi dash from this pyramid, and the lower one, you will have flux phi dash. If it becomes a Gaussian surface, the total flux, this is total electrical induction will be E dot A is how much? 1 by E0 times Q. So 2, that means phi total from this closed Gaussian surface. The green one has created the surface. I have made a Gaussian surface. Okay. Initially, the black one was your pyramid, which was given to you in the question. And the Q was sitting inside. We have to find out the flux from any one of those, from the one of the 4 identical faces. So you make first a closed figure. And the figure has how many flux? One is the upper pyramid is phi dash, the lower one is phi dash. So 2 phi dash, like you had in the semi-cylinder one. Okay. So 2 phi dash is 1 by E0 times Q. So phi dash will be Q by 2 E0. The flux through one of the face will be 1/4 of this one. So Q by 8 E0. So it will be option C. Okay. Now there's another one. You are given 2 parallel plates. I have also given the text for you in the slide number 3 of 2. There are 2 parallel plates. One is a positive plate and the other is the negative plate. And the surface charge density is sigma in both. Okay. The plane sheet of charge with surface charge density sigma. Find the field at point A, point B, and point C. A पहले लिखने का है, B then C. So chronologically A, B, C, the options are given. The field at A. What will be the field at A?
E1 plus
Where the-
E2.
Yes, because the field due to just how will you explain the students? This point A, the flux, this positive plate, it will be going outward. So it will be going beyond positive plate. So it will be going towards negative plate. Now field due to the negative charge, it will be going inward. So both of them are directed in one direction. So it will be sigma by 2 is 0 plus sigma by 2 is 0. The field due to point A is sigma by E0. So you have sigma by E0. Okay, the point A. And then where is your point B? This is E2 and E1. They are all cancelling with each other. It is 0. Similarly, what is C? ER is 0. So these two are zeros and the middle one is sigma by E0. So just actually this should have been point A, B, C. This is written wrongly. Please change it. This part is A, this is B, this is C. Otherwise, okay. So one of them is only sigma by E0. So that means this should be your A, this should be B, and this should be your C. Okay. So A will be 0, B will be sigma by E0, and then C is 0. So this should be this part instead of A, this 2 I have to change it. Please change it. This part is A and this is B and this is C. Okay. Now, according to Gauss theorem, electric field of an infinitely long straight wire is proportional to
1
I
by
have
R.
just showed you 1 by R. So the answer is 1 by R immediately. I have just showed you that Gaussian surface. Now, the electric flux for a Gaussian surface is enclosed surface A that encloses 3 charges. What are the charge particles? Given Q1 is minus 14 nanocoulomb, 10 to the minus 9. Q2 is 78.85 nanocoulomb, 10 to the minus 9 coulomb. Q3 is minus 56 coulomb. And then calculate the total flux. What will be the total flux? You calculate. The total flux is simply equal to how much? 1 by E0 times charge, total
Q
charge.
total by epsilon naught.
Q by epsilon naught. Epsilon naught is 8.85 into 10 to the minus 12. You must know that. And then you, what is the charge here? 14 into 10 to the minus 9, 78.5 plus into 10 to the minus 9. And then this is minus 56 into 10 to the minus 9. If you calculate this minus 14 and minus 56 gives you minus 70 into 10 to the minus 9. So this gives you 8.85 10 to the minus 9. Down below you have 8.85 into 10 to the minus 12. 8.85 cancels. You'll get simply, you go take it up, it will be 10 to the power 3 Newton meter square per coulomb. So this will Newton meter square per coulomb is option A correct. Now this is the inward and the outward flux for a closed surface in units of Newton meter square per coulomb, because that is the unit of flux. Respectively are 8 into 10 to the power 3 and 4 into 10 to the power 3. The unit is given here. Up inward is red mein hai, and the outward is in blue. Okay, the inward is in larger number and the outward is in smaller amount. But inward is minus 8 and the outward will be plus 4. Both of them have the same 10 to the power 3. Okay. Just take it out, take this part. So what will be this? Phi is equal to Q by E0. So Q, you have to have the total charge. Q is phi into, that means E0 phi. You have to find out the total charge. The charge in coulomb. Okay. So total charge enclosed will be, sum of the fluxes will be minus 8 inward, plus 4 is the upward, which is outward is positive in nature. So this will be minus 4 into 10 to the power 3 into E0. Minus 4, 10 to the power 3 dono mein hai, but you have E0. So you have here in the option D E0. So this option D is correct, not C. Now again, this is you immediately you can answer this is option D, because a charge Q is placed at the center of a cube, then the flux passing through one face of the cube. Again, this is a closed figure. 1 by E0 times
6
Q.
epsilon. Q by 6
faces,
epsilon.
yes. Yes, 1 by 6. Yes. Next, this is an important thing which you must tell the students about the dipole. An electric dipole is
Zero.
put, no, yes, north-south direction in the sphere filled with water. Which statement is correct? The flux coming towards the sphere, the flux coming out of the sphere, the flux entering into the sphere and leaving the sphere are the same. Water does not permit electric flux to enter the sphere. The D part is totally wrong, because water has permittivity. That goes out.
Yes.
Electric flux,
Yes, ma'am.
it has permittivity, it permits. So electric flux is coming towards sphere. You cannot do that. Yeah, this C option looks correct, because if you have a dipole plus
They're
This is
entering
two
it,
opposite
equal to
charge.
leaving.
Yes, the flux coming in and going out, they are the same. The inward flux and outward flux. So total incoming and outgoing, the net is 0. So you can say that electric flux entering into sphere and leaving the sphere are the same. The option C is correct. Here must tell them about the dipole. Now SI unit of electric flux in from this part. This option C will be correct because flux is Newton meter square by coulomb, right? And what is Newton into meter? Joule. Joule by coulomb क्या होगा?
Sorry.
Volt.
Magnetic
Joule.
flux.
Newton into meter is joule. Joule by coulomb will be volt. So answer will be volt meter. देखो. Newton meter square by coulomb. Meter. So Newton meter is joule. Joule by Q by V. It's like that. V by Q is like that. So volt. Okay. So you have
Yes.
joules. Work done. Work done is QV. So volt is work done by coulomb. So the joules per coulomb is volt. Volt into meter. So this option C is correct. Now again this part, dipoles, plus minus. So 8 dipoles, they are negative, they are all cancel each other. So the option will be 0. Because 8 dipoles of charge of magnitude E are placed inside a cube. Closed figure hai. Again, you have a symmetric charge distribution, total electric flux coming out of the cube. 0. So I have done this part. I want you to solve this. A charge Q is located at the center of a cube. Imagine the cube, center mein charge hai. The electric flux through any phase. It will be 1/6. Yes, 1/6. But we know 1/6 of Q by E0. अब इसमें तुमको पहला is 4 pi डाल दिया है. But this 0. So you can think it is 1/6 Q by E0. But rest of them, you see, these are all 2 pi Q, 6 into 4 pi. So I think this 4 pi, this looks, the option A looks correct. So it will be 4 pi Q, 6. Don't take any CGHS. It is simply Q by E0, 1/6 is the answer. But simply to just to dissuade you, it is 4 pi. Okay? Now consider the charge configuration of the spherical charge configuration and spherical Gaussian distribution. This is the last slide. Winding up here. Surface as shown in the figure. When calculating the flux of the electric field over the spherical surface, the electric field will be due to Q2. There are 2 charges inside and 1 charge outside. Due to Q2, only the positive charge, all charges Q1 minus Q2. The answer is all charge. You know why? The plus Q ka flux away jayega, minus Q ka inward aayega, and Q2 will also have some flux, it will have some electric field. This is also will be contributing to the sphere. So it will be due to all the charges. So I wind up here. We'll be having the next session after some time.
Excuse me, madam.
Yes.
Ma'am, actually, I have one doubt, ma'am. Hello? Hello? Hello?
हाँ बोलो. Yes, please.
हाँ मैडम, एक्चुअली एक क्वेश्चन में मेरे को डाउट था मैडम. क्वेश्चन का एक प्री बोर्ड का क्वेश्चन था मैडम, जो रीजनल ऑफिस में आया था एक, वो 2 मार्क्स का क्वेश्चन था. तो उसमें पूछा था मैडम, 2 plus Q charges are there, and 2 plus Q charges, small q charges are there, and one capital Q plus Q charges is placed in between, such that the force between them is maximum. So what is the actually the distance between the 2 plus Q charges? The small q charges is x, and the capital Q is placed at a distance of small d. At a distance of small d.
Yes.
On the axis.
Yes.
Then if the force is maximum, then what is the relation between x and d? Madam, on the axis I can calculate, ma'am, no problem. But
if the force is maximum, the distance will be very small between them.
No, madam, because the options are given.
Yeah, they are in the vertices of the triangle.
No, madam. On the axis, 2 capital Q charges are there, and in between the 2 capital Q charges, one small q charge is placed, and that is at a distance of d. And the distance between 2, yes, ma'am. And the distance between 2 capital Q charges is small d. And the force is maximum, it is given. Then it is asked that what is the relation between the x and d.
You can simply, if the force is maximum, you have
Madam,
can,
yeah, on the axis I can calculate, ma'am. No problem. I have calculated. It is x equal to d. The relation it is
X equal to
came out.
D, yes,
But
yes.
yes, yeah. But the next question is given on the same
Huh.
question that the that small q charge is placed on the equatorial line and at a distance of x. And now what is the relation between x and d?
It is on the
That
equatorial
one
line.
I have. Yeah, yes, ma'am.
Okay, I understand. Is it in the equatorial line?
Yes, ma'am. It is on the equatorial line and at a distance of small x. And initially the distance between the capital Q's are small d.
Small d.
Okay, so what will be the force between them is maximum. So
The force
you
it's
can
given. It is given, ma'am. It is given. The force is maximum. It is given, and the relation between x and d. What should be the relation between x and d?
okay. You can integrate. You can differentiate. If it is maximum, the distance that has to be df by dx would be 0. Just find out the relationship between x and d from there.
I could not able to calculate, ma'am. Actually, it is given
Okay,
in the
yeah,
question.
you send it. You
CBSE
send it
paper.
to me. Send it to me. It's a very. It sounds simple. So figure that down. Okay.
Actually, in that group, I will send now.
Sure.
Sure. Okay.
ଟିକେ ରହିଯା ମୁଁ ଦେଖିଦିଏ ଟିକେ ଚେକ୍ କରିଦିଏ ନାଇଁ ବୋଧେ ଏଇଟା ମୁଁ ଦେଖିଦିଏ share ହୁଏ ତ ନାଇଁ କରନ୍ କଣ ଏମିତି ହେଲା
I have sent a question in EMRS physics training group.
Okay. कौन असला नहीं मोर जगह
EMRS physics training group. I have sent the question, ma'am.
मोर मो पॉइंटर टा भी पाउनी ना तमे एटा कलारो
Hello. Hello. Hello.
ठीक है just 1 minute
Hello.
हाँ कहीं इधर इटा मिनिमाइज क्या है ना वो पॉइंटर टा मोबाइल करो इटा टिके ऑफ करियो गो बैक तो जाओ नहीं इटा तुम्हारा इटा जीवो की माउस भी नहीं इटा इट्स नॉट गोइंग सो ओनली दिस की इज कमिंग इटा बंद करो तुम्हें बंद करो आई एम हैविंग प्रॉब्लम विद दिस
मैडम
यस प्लीज
हेलो हाँ मैडम इसको ग्रुप में सेंड कर दीजिए सेंड कर दिए हैं मैडम वो फिजिक्स की EMRS ग्रुप में
let me finish the second session I'll send it to you the answer okay sure
yes ma'am yes ma'am
and
okay.
after this class I have another one in continuum
okay ma'am thank you
I just have another with you with the potentiometer and the bridge after that I'll be talking to you see wait just wait 1 minute no can't এটা জমা দাও না তোমার এটা কাই আসছে না my pointer is not going full length what am I doing now point এটা ফুল করা হয়েছে না escape করে দাও escape भी हो नहीं তোমার তোমার संगे लागे বলে हो नहीं पॉइंटरটা you don't have a pointer देखा भी जाओगे कि बहुत हरान होची से पॉइंटर टा नहीं बोले बड़ा इडी पॉइंटर नहीं किला इटा पेंसिल थी इटा कौन था तमरो हां इठी छटा देखो जो इठी আছে ओके इटा मैक्सिमाइज इठी अपन एति के हबो जूम कर दे इठी इटा ओ मो नहीं इठी चलेबो आगो इटा मार दे इटा पॉइंटर लगे दिया स्ट्राइक करी तब इटा सब तौल को मिनिमाइज कर इटा स्क्रीन टू इटा हां इटा यार पॉइंटर लगे दिसुने पूरी एटा बॉन्ड भी हो इटा लास्ट टाइम यार टिकन पॉइंटर है इटा कौन लगे दी it's somewhere here you know let me see resume slide so देखिए let's see ना छोड़ो waiting to activate ସେଇଠି ପଏଣ୍ଟ ତମ ଥିରେ ପଏଣ୍ଟର ଥିଲା ହଁ ସେଥିପାଇଁ ହଉଛି কোটা এটা পুরো এমসিকিউ ফোনস লো এটা 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 ହେଲା এটা ତଳକୁ କରୁଛି ମିନିମାଇଜ କେୟାର କରିବି ତ मिनिमाइज कर ली शेयर जोन रहा रन करछ कोडा शेयर तो करी में हमें देखो ये नहीं न्यू शेयर तो स्टॉप शेयर जल्दी करो हाँ এটা ক্লিক করো সেটি শেয়ার এটা জুম কাহিকি হবে না এটি আর এটা আমি পেন্সিলটা দেখো সাইড শো দেখো ओके चलो তোমার পেন্সিলটা এটি ओके चलो करिया सेंट पॉइंटर न कले बहुत खराब देखा जाय एटा सी पॉइंटर तो ब्लैक ये थिला एटा कोन केमति आथिला एटा देखियो कोन कलर एटा गला गला सब स्टॉप शेयरिंग करो it is future नहीं इतने बड़े कहाँ खुल गया ना ହେଲା okay will be good afternoon this is 12:10 now I think we will have the second session and dear teachers if you have any doubts please put it in your in the WhatsApp group last time I also explained some persons about this individually they had sent me in the WhatsApp so you can do that and if you have any numericals which are of real value to the students you must share with all of us I would also like to share some of them also okay so let's begin with the MCQs for Ohm's law, drift velocity, KCL, that is Kirchhoff's current law, and the Kirchhoff's voltage law, and the Wheatstone bridge if possible. Okay, so here when we start with the slide, before we start with the MCQs, you must throw light on Ohm's law, that is the temperature remaining constant, the potential difference V across a resistor is equal to the product of current I and the resistance. So V is equal to IR. That's everybody knows. But there is a current density term, capital J, which is equal to sigma times E, where sigma is the conductivity of the material and E is the electric field. Now, this part, the Kirchhoff's nodal law, the junction rule, which is also node law, we all know that the algebraic sum of the current meeting at a point is 0, or you can say the algebraic sum of the current entering a point is equal to the algebraic sum of the current leaving it. So that is in net, it is I and n going from 1 to capital N is 0 summations. Now, Kirchhoff's voltage law is also called a loop law. And here we say that in a circuit, suppose you have, this is the battery which you have internal resistance small r, the EMF is E, and then it is going through a resistor. There is a current I is flowing. Then in that case, the potential drop, you must explain the students that if you are traversing the current, if you are traversing in the direction of the current, there will be definitely a drop across this resistance. That means the circuit, if you are traversing in the direction of the current, there will be a drop across this R. So the potential drop will be minus I into small r. So this R, so if you have the total EMF is the maximum potential difference in the open circuit. So EMF E is equal to, you can say that IR minus IR. That is IR minus R. Okay. So if you, sometimes it so happens that if you have an increasing supply of current, that means when there is a battery supply is being increased, then you will have this R plus R. You cannot have IR minus R, but it will be IR plus R. So here I have written E minus IR, that means suppose you this voltage across this R, this is, please see this, the capital V is equal to I into R, that is Ohm's law. Now IR is equal to EMF E minus I into small r. Now E minus IR is equal to capital plus IR, or you can say E minus IR minus IR equal to 0. This is your KVL. But what I am trying to tell you is, please note that it is not always E minus IR. E minus IR, there is a drop only when you are traversing along the direction of the current. And if the supply is increasing, it might become E plus IR. Okay. So this is what you must refer to. Now next is the drift velocity and the mobility. This is also a text which you must throw light on. The drift velocity per unit field strength is mobility. But what is drift velocity? Drift velocity is defined as the average velocity with which the electron gets drifted towards the positive end of the conductor. The average velocity with which the electron gets drifted towards the positive end of the conductor under the influence of electric field. Do you getting it? Yes, please. Am I audible?
Yes, ma'am.
And what is mobility? Mobility is drift velocity per unit field strength. So drift velocity and the mobility, what is the unit of mobility? It is m square v minus 1 s minus 1. Now current and mobility, you will also show the difference. The conventional current, which is I is equal to dq by dt, rate of flow of charge, this is q is I delta t, that is I is q by delta t, and n, number of electrons is I into times delta t. We can say that INE delta T is E into I, where is the electron current. You must also show the difference between the conduction current and the displacement current. That part also should be explained. And the current density here, since the current density is simply equal to J, that is sigma times E, and sigma is NE square tau by M. T is the time, NE square tau by M, and 1 by sigma is resistivity, and 1 by rho, that is resistivity, is conductivity. Now, the resistivity of an insulator, conductors, there are so many objective type questions on conductivity and resistivity, which you can definitely discuss in class. All of that we cannot explain in single one unit. So that part, I leave it to you. Next, there's another important concept which you must tell them when you are talking about this internal resistance, the potential difference and the terminal potential difference and the EMF. EMF is the maximum potential difference in the external circuit when the circuit is open. Now, and what is the incorrect sentence here? This is the question. Find out the incorrect sentence. Before that, I must tell you about the internal resistance. You have two electrode, positive and negative electrode, and a sodium chloride. Suppose any electrolyte is there, and there is a circuit completed, and you have electrons are passing. They're getting flown. The flow of current is going on. Now you know the internal resistance will increase. When do you have this? It will depend on the 4 factors. One is the distance between the 2 electrodes, then the temperature. It also depends upon the concentration of the electrolyte. It also depends upon the area of the electrode. Now, if you increase the area, the resistance decreases. If you decrease the area, the resistance increases. That means inverse ratio to the area. And then inverse ratio to temperature also. Because if you increase the temperature, the resistance decreases. So inverse ratio to 2 factors, temperature and area of the electrode. But it is direct ratio. The internal resistance is in direct ratio to the distance between electrodes. That means जब distance बढ़ता है, R goes on increasing. And if the concentration of the sodium chloride or any other electrolyte goes on increasing, whichever electrolyte you have taken increases, the resistance increases. So direct ratio to the concentration and to the internal resistance increase to the distance between the electrodes. So here, let me go through the first sentence. Internal resistance increase with decrease in area. Correct? Because it is inverse ratio to the area. Internal resistance R increases with increase in distance between the 2 electrodes. Direct ratio. Correct? Internal resistance increase with increase in concentration. Correct? Because it is in direct ratio to concentration of the electrolyte. Internal resistance increases with decrease in temperature. That's also correct. So what are the options? A1 no, B4 no, C3 no, none of the above. So this is the correct option. Next. Now suppose you have a potentiometer wire which is 100 centimeter long. And let me read the question. Resistance of 100 cm long potentiometer wire is connected to a battery of 2 volt. It is connected to a battery of 2 volt. So let me take the laser pointer. It is connected to the battery of 2 volt. Now this is the internal resistance of this wire is 10 ohm. Okay. Now the potentiometer wire is connected to a battery of 2 volt and resistance R is in series. अब इधर R नहीं लिखा है, but R is in series दिया हुआ है. Okay. And then a source of 10 millivolt gives a null point at 40 centimeter length. Then the external resistance, what is the value of the resistance? If a 10 millivolt source gives a null point at 40 centimeter, what is the value of R? The options are 490 ohm, 790, 990, 590. This R, I mean the R which is in series with the 2 volt. Now please read this question carefully. The length of the wire kitna hai? 100 cm. What is the voltage? What is the potential for this wire? 100 cm wire. Current into the resistance 10 ohm. So I into small r, you have the potential on the wire is capital I into small r, potential on the wire. Now what is the potential per unit centimeter of the wire? I into R by 100. इधर हमने क्या लिखा I into R by L, because I have taken L and later on I have put it 100. Okay, I into R by L or I into R by 100, you can think. Now X is the potential per unit cm. Now this is potential. Now if you have this, multiply I into this I, you have E, this is I by L into small r. So what is I? I is EMF, R and R is in series. You know this is a standard result of I. The current in the circuit is EMF by R plus R. Please check. I have told you two things. एक तो X is X का direct formula is IR by L. Is it clear? IR by L. And what is your I? IR by L, because L is 100 cm and IR is the potential on the wire. Fraction X is potential per unit length. So I into R by L. So I is E by R plus R. L idhar hai and this R is here. This R is here. So E by R plus R divided by L and multiplied by R. That gives you the potential per unit cm. So 1 centimeter mein this much of potential difference is there, potential is there, developed. In 40 centimeter, how much potential will be developed? LCM. So you multiply small l. So you have E by R plus R into R by L, which is 100, multiply by 40 cm. So this is all you have for 10 millivolt. So 10 millivolt is equal to E by R plus R, which is your I, into R divided by L, this is potential per unit length, multiplied by small l, which is 40. Small l is 40, L is 100, R plus R we do not know, which I have taken it this side, and 10 millivolt is here. 10 millivolt is ER by R plus R. And what is your value of small r? 10 ohm. R plus small 10 ohm is equal to 2 volt, E is 2 volt multiplied by 10 ohm, small l is 40, divided by R plus R has gone this side. So 10 millivolt is 10 into 10 to the power minus 3 volt. This is your 10 which has come from this side. 10 millivolt is come denominator mein. And then you have L is 100. You have 40 and L. This is L by L. This is your R, 10 ohm. E is 2 volt. R plus R is gone to the LHS. And 10 millivolt has come in the denominator. Now calculate this. This comes 800 ohm. Just check. This 4 into 2 is 8. And then you have 10 to the power 2. All this 10 to the power 3 goes. You have 2 cancels. So 10 to the power 3 up. And this 110 is here. So you'll get 800 ohm. 800 ohm is equal to R plus 10 ohm. R is equal to 800 minus 10. That is your option B, 790 ohm. Next. A battery with a constant EMF and internal resistance small r provides power to an external circuit. Okay? Provides power to an external circuit. With a load resistance made up of connecting two in parallel, RL and 2RL are in parallel to each other. For what value of RL will the power delivered to the load is maximum? Please understand that the load is maximum. The power delivered to the load is maximum when the external resistance is equal to the internal resistance. Students, please see this, that this Ri, I have taken it as small Ri, because just to give a difference between them, because in the option it is small Ri. So this is small Ri. Okay. Now, what are the two RL and RL are parallel to each other. Effective resistance, how much? 2RL into RL by 3RL. Product of 2 by sum of 2. This is the effective resistance. RL into RL by 2RL plus RL. This is 3RL. So R is equal to 2RL by 3. Now, this R should be equal to your Ri. So Ri should be equal to 2RL by 3. This is not your option. Your option is what is your load resistor. So load resistor RL is simply 3 by 2 Ri. So what is your option here? 3 by 2 Ri. So option D is correct. Is it clear? Yes, please.
Yes, ma'am.
Now the condition for validity of Ohm's law. You have 3 of them. Current should be proportional to voltage. Resistance of the wire of the Ohm type. Temperature should remain constant. All of the above. You cannot have this proportionality. The Ohm's law condition is temperature remaining constant. V is proportional to. Okay. Current is proportional. V is
Yes.
proportional to current. So this is what temperature should remain constant. Next, Ohm's law is not applicable to semiconductor, DC circuit, small resistor, high currents. It is C and D
Semiconductors.
wrong. It has to be semiconductor because diodes are the ones where you have the EMF. That means there will be kink. So initially you will not have Ohm's law there. Now here, this is the expression of resistance is rho into L by A. You know, resistance is directly related to L and inversely ratio to A. So rho is the, what is your rho? Rho is the specific resistance. Okay.
Resistance.
The wire is stretched. No, sorry. If the wire is had to be double its length, and now new resistance. Find out the new resistance. If the wire is stretched to double its length, find the new resistance if the original resistance of the wire is R. Now you know that is rho L by A. The new resistance is R dash, which you have to find out. Rho is a constant, that is the nature of the material. So rho is constant, L dash by A dash. You know that there is a conservation of volume. So when L changes to 2L, that is L dash becomes 2L, A dash reduced to A by 2. So you can say that means so that the volume remains constant. So you can say area becomes half. So in place of L, you write 2L. In place of A, you write A by 2. So what is the value of R? 4R. So your option is 4R. So next, the wire is stretched to increase the length by 1%. Find the percentage change in resistance. This you ought to know, students, because R is rho L by A. Now, if you take before I go to this question, in practicals, none of you do errors. The log RL is log rho log L minus log A. That means if you take a log R, log of rho L by A, and then differentiate, you'll get delta R by R equal to delta rho by rho plus delta L by L minus delta A by A. First take the log and then differentiate. Then you know that maximum log error, you can always take a plus sign. So that's why I've changed this minus sign to plus. When you do an experiment, we always find out the maximum log error. So in a resistance experiment, in a Ohm's law experiment, we always take in this form in a plus. So total modulus positive lena has go. So delta rho will be 0 because rho is a constant. Delta L is changed by 1%. Delta L by L is 1%. Now you know when L changes, A also changes by 1%. So A 1%, L 1%. So 2%. So option D is correct. Okay. Next. The potential difference of 100 volt is applied across a conductor of length 50 centimeters. A potential difference of 100 volt is applied across a conductor of length 50. You have been given 100 volt, you have been given length. V by D, you will calculate E. Calculate the drift velocity of the electron if the electron mobility is given is 90 to 10 to the power minus 5 m square V minus S minus. We know that electron mobility is drift by field strength. Now drift will be electron mobility multiplied by field strength. So electron mobility given multiplied by the field is 100 volt by 50 cm or 100 volt by 0.5 meter. So you take the mobility, that is 9 into 10 to the minus 5, that is multiplied by 100 divided by 0.5. That gives you 0.018. Calculate it yourself, please check. 0.018 ms inverse. So you will get the option C to be correct. So next, you have now here you have to find out the voltage, the value of this V. The question is not given in the circuit. Calculate the value of V, this V. Now this V is parallel to V2. Okay, so you can say that you can find out this V2 and hence tell about V because V is parallel to V2. So they have asked what is the value of V? Option is 10 volt, 12 volt, 14 volt and 16 volt. Before I go to this problem, you must know that this arrow mark given is what kind of a source is this? Current source. It's a current source. And what is the value it is given? If you a current source and you have been given a current there, it will be a current source current dependent. If you have a voltage, it will be a current source voltage dependent. This you must tell the students. And if you have a circle having plus and minus sign, it will be a voltage source. So you have a current source here. Then there is a resistance. There is I5, I10, and then there is a 2 ohm. This is a 10 ohm. Okay. Now you can apply here in this node the KCL. So KCL at node 1. So that will be I5 equal to this I5, which is going towards the node. I5 is equal to I10, which is coming this side, plus I2. I10 plus I2 is equal to I5. So, and then I5 is I10, which is your 6. And I have to calculate your, you should calculate your I2 equal to I5 minus I10. I5 is given as 6 ampere. It is given. Please note down. I5 is 6 ampere. So 6 ampere minus 6 ampere minus I10. How will you calculate I10? See this, there is a 10 ohm. And what is the voltage across the 10 ohm? It is written 20 volt. Please write down. V1 is 20 volt. V1 20 volt, and there is a 10 ohm. So what is your I10 here? 2 ampere. I mean, you can calculate that. So the voltage, the current through the 10 ohm resistor is V1 by 10, which is V1 given as 20. So 20 by 10 is 2 ampere. So you have been given 2 ampere. So current through the 10 ohm resistor. And what is that? 2 ampere. So that is subtracted. So this will be your I5 is 6 ampere minus I2 minus I10, which is 2 ampere. So 4 ampere comes. Now 4 amperes. Now you have a 2 ohm resistor, which is going here. The 2 ohm. So this current 4 ampere is moving this side. So what is this? This is 2 ampere. This is 4 ampere. And what was given here? 6 ampere. KCL is satisfied. And this node, this is 6 ampere. And you have calculated this as 4 ampere, this 2 ampere. And what will be this? 4 ampere. Okay. Did you get it? Should I repeat it? This part is 10 ohm. Okay. Now this is 20 volt. What is the current through the 10 ohm resistor? 2 ampere. Now this part is given as 6 ampere. This 6 ampere is going towards the node and 2 ampere is going away. What is this ampere? This will be 4 ampere. So what is the voltage when 4 ampere is for 8 volt? So the voltage developed uh, 12 volt. Now since this is the voltage V across this. Internet is unstable. The voltage V is parallel to this. So you can get the value 12 volt. Now the next one. The resistance of a heating element at a temperature 27 degree is 200 ohm. Resistance at 27 degree kitna hai? 200 ohm. At what temperature? Temperature is to be asked. The resistance will become 218 ohm. If alpha, temperature coefficient of resistance, is 1.8 into 10 to the minus 4 per degree, 1 degree. Okay, you can see this centigrade. So T is 27, R0 200, R final is 218. What is the formula? RF is equal to R0 1 plus alpha delta T. Delta T is T minus 27. 1 plus alpha into T minus 27 is equal to RF minus R0. Or you can take RF minus R0 divided by R0 alpha gives you T minus 27. So RF is given 218, R0 is 200. So the numerator is 18 divided by 200 into alpha value 1.810 minus 4. This plus this T minus 27, bring the 27 this side. So T is equal to 27 plus 18 into this 10 to the power 4 you can bring up 10 to the power 4 divided by 1.8 into 200. This gives you value 500 plus 27, 527 degree. So the option is 527, option C. Next one. Calculate the equivalent resistance in the circuit. Here you must have to tell them about the mirror symmetry. You cannot have a fold. Here you have RR, you have AB. You have to calculate the equivalent resistance across AB. Okay? Now there is R2R here, there is RR here, there is RR here, and RR here. Now see this, more than, if you see this, even you have more than 4 to 5 resistances, you must think of a Wheatstone bridge. Okay, so PS, that is RS, that is PQRS. What is the formula? That is this multiplied across the opposite. R into R is equal to R into R. So this is, you can remove something like that. Okay, the diagonal portion can be removed. Now think of draw a mirror line here. You cannot have a, so note, no folder symmetry is possible at AB in this figure. You cannot have a folded symmetry. So you can have a mirror symmetry. Now think of this. From point A, current I is moving. I2 idhar ja raha hai, I1 idhar. So total I is I1 plus I2. Now I1 goes like this, through this R and through this R, and comes towards B. Now just see this node. This node is not touching this one. It is going on it's a mirror symmetry. Now here, this R and R, this I2 is moving. It goes through this flows through this. So I2 flows through this R, and I1 goes from this R. I1 plus I2 come back to B. Okay, so you can just unfold this to R and R to the upper part. Now what is this system here? This R and R is in series. This and R and R in series. Those 2R and 2R is in parallel. So what is the net of this figure, this part? Net is 2R into 2R by 2R plus 2R. What do you get? 2R into 2R by 4R. What do you get? The effective R. The value is R. And then you have R here. So this is all series connection. R. This is effective R. And this is R here. So total is 3R. Is in parallel to 2R. This R and R is 2R. So I have put a diagram like this. A. Upar wala ka A effective ho gaya R. And this is R here. This is another R here. So this is 3R in parallel to the down below length, which is in straight line. This is 2R. So 3R parallel to 2R gives you the parallel 3R into 2R by 3R plus 2R. What do you get? 6 by 5R. So the option C is correct. 6 by 5R. Okay, so this is mirror symmetry. Now this is very easy. This is KCL. This will have been in the beginning only. Now 10 ohm and 10 amperes. That is, you are getting a 5 ampere current and a 10 ampere current is going to the node. So what is the value of this? So it will be 15. Going ahead. KCL. Now calculate the current across 20 ohm resistor. Now again, this 20 ohm resistor. Now you have to apply the think of it that low terminals are in 0 volts. Okay, you have to calculate V across the 20 ohm. V matlab you have to calculate current multiplied by IR, I into 20. That is there. I into 20 has to be the answer. So 20 multiplied by the I. Now calculate this current. How?
Sir, काली training होची ना आपण करो.
Yes. What?
हाँ सर मैं दे देवी हो क्वेश्चन मोर तो 2 तारीख अच्छे
क्वेश्चन कर दे
हम क्वेश्चन कर देवी छुट्टी अच्छी तो 2 दिन छुट्टी नहीं ना रविवार सोमवार कर देवी तातर
So here
आप सर इंग्लिश सर कर दीजिए
ए कर देले बिनी एगोटा आजि पके
the low terminal, the voltage across this, suppose the voltage across this 1 ampere is V. Now assume that low terminal 20 ohm is at 0 volt and this is V volt. Okay. Then the upper terminal is V volt. Now you apply KCL. What is this current? This current 1 ampere. 1 ampere is equal to, what is this? 1 ampere is equal to V by 10 plus V by 20. V by 20 plus V by 10 is equal to 1. So now calculate the V value. V will be equal to 20 by 3 volt. Just calculate this line. V by 10 plus V by 20. Take the LCM 20. This will be 20 by 3 because the RHS you have only 1. This is 1 ampere. I have applied only KCL, Kirchhoff's current law. Current through 10 ohm, current through 20, and this is 1 ampere. So I have taken 1 ampere is equal to V by 10 plus V by 20. And I calculated V as 20 by 3 volt. Knowing V, what will be the current through the 20 ohm resistor? Since these are parallel, this 20 by 3 volt multiply by 20. 20 by 3 volt multiply by, divide by 20, V by R, because that will be current. So this 20 cancels, you will get only 1 by 3. Okay. This is V. V is 20 by 3. Divide by the resistance 20. So you get 1 by 3. So answer is the option D, 0.33 ampere. Okay. Now KCL deals with conservation of momentum, mass, energy, and charge. It is conservation of charge. Now calculate the value of V1 and V2 in the following circuit. Now look at this. Using KVL, you have 12 volt here, you have a V1 here, and you have an 8 volt here. Now, how will you tell the students? When you travel the circuit, you always see the final part in every component. It is positive, so either write 12. Now, either when you go to V1, it is negative, you write minus V1. Here, when you come to 8, it is negative, you write minus 8. So 12 minus V1 minus 8 is equal to 0, KVL. So what is V1? V1 is 12 minus 8, 4 volt. So एक 4 volt का option तो आ ही गया, you need not do, but still let us calculate the second circuit. Now second circuit, you apply again KVL to the circuit. So algebraic sum of voltage is 0. So here this is positive, so first positive 8 volt likha, then V2 is negative, minus V2 likha, then you come to here minus 2, so minus 2, 8 minus V2 minus 2 is equal to 0. What is your V2 then? 8 minus 2, 6 volts. So V2 is 6 volt, V1 is 4 volt. So 4 volt and 6 volt is the option. 4 and 6, A. Option A is correct. The next one is very easy. Calculate the voltage of the 10 ohm resistor. You know the total. What is the voltage divider method? What is the voltage divider? Yes, can anyone tell me immediately? What is the voltage across 10 ohm resistor? I into R, 10 multiplied. Now what is this? How will you calculate this? Using the divider rule. What is V equal to? Yes, please. What is the total? Yes. এটা দেখা এটা টিকে টেকি হবো কি তাଙ୍କୁ দেখেই দেবা টিকে Yes, please. Oh, no, that's the other one. Yes, I leave it you to calculate. I give it 1 minute. Pause and do it. What is the total? This is 12 volt is there. What is the total resistance in the series? 10 plus 5, 15, 15 plus 15, 30. Okay. So total resistance is 30 and voltage is 12 volt. 12 volt by 30. What do you get? V by R. Okay. So this is I. So I is 12 by 30. Multiply by, you will get the voltage. So current is 12 volt divided by the effective R. 12 volt by effective R is how much? 12 by 30. This is the current. 12 by 30 is the current. Now the question is, what is the voltage across 10 ohm? So 10 ohm into 12 by 30. It is a very simple question. So this is 4 volt. Is that clear?
Yes, ma'am.
Okay. Now here I have the here I have there is a branch which this is not seen. Let's go to the next slide. This slide is not being able to see. The slide has to be shown. Make the slide proper here. The slide, the students cannot see the slide. They can't see the figures. Let me go back. Stop हो गया से जगह उठे स्क्रीन को जीवा इट जा yes. Yes, I want to show them the full slide. Let them see the slide. How will they know otherwise? Look, there is a voltage, 20 volt. This is 25 ohm, 15 ohm, 40 ohm, and 10 ohm. These are in series. These are in series. Now you have to find out the voltage across AC. The question is here. This is 20. Now what will be the total effective resistance? This is 25 plus 15 is in series. So, and this is 40 and 10 are in series. Now calculate the effective resistance. We have to calculate, you have to add voltage law to A, B, and C network. Okay. So for the branch AC plus BC, AB, BC, and CA is 0. So you have to calculate across the voltage across The question is down below. Let me see what is given to you. VAC. Now VAC, A and C. This is A, B, C. VAC. You have to calculate the voltage across AC. Voltage means what? 50 resistance multiplied by current. So 15 multiplied by the current. What will be the current? Current will be voltage by the effective resistance. Voltage is 20 volt. Effective resistance 25 plus 15. So 15 multiplied by 20 by 25 plus 15. That gives you 7.5. So voltage across AC. This ABC are there in the figure. So voltage across 15 ohm, that is voltage across AC is I into R. R is your 15 ohm and I is 20 divided by 25 plus 15. And that gives you 7.5 volt. Is this clear? VAC. Now what is across branch BC? B and C, what is the ohm? 10 ohm. So I into R, that is R is 10 ohm multiplied by I, which is your I, same I. 20 divided by 10 plus 40. Here I told you 40 ohm was in series with 10. So 20 divided by 50. So this gives you 20 by 50 into 10. This gives you 4 volt. Now simply add, make Kirchhoff's law. VAC, BC and CA. So that will be VAB plus VBC plus VCA to the loop ABC. That will be equal to 0. So 7.5 minus 4 gives you 3.5 volt. So the answer will be option A. So option A is correct. So option A is correct. Just keep it in the option. Which is this one? This is all gone. So let's go to this one first. Then which of the following graphs IV represents ohmic conductors? Very simple. Ohmic conductors obey Ohm's law. Definitely. So the option A will be correct. These are all semiconductors. Okay. Now, which of the following graph is of a good conductor? Option A, because ideally a good conductor will not be exactly like this, but it will be slightly a deviation from the straight line. So option A again for this one. So option A is also for the good conductor. Now, this part, what is the effective resistance across AB? You have from A to B, what is the effective resistance? You have a 1 ohm in series and there is a bridge network. 3 ohm, there is a 9 ohm, then you have a 1.5 ohm towards B, then you have a 5 ohm here and a 15 ohm here, and in the diagonal you have an R. This is simply like a Wheatstone bridge network, more than 4 to 5 resistance. So what will happen is, multiply you oppositely, 15 into 3, 45, 9 into 5, 45, which is a totally Wheatstone bridge conditions, balancing condition is totally satisfied. So remove R. You must tell the children that you must multiply this one or make a ratio P by Q is R by S, whatever is easy, whichever is easier. For me, it is 3 into 15 and 9 into 5. So remove R. So if R is removed, what will happen? You can say that the effective R will be, what will be effective R when you remove R? 3 and 9 will be in series and 5 and 15 will be in series. So 9 plus 3 is in series, 15 and 5 is in series. Now they become parallel to each other. So first find out the effective resistance. 12 and 20 ka parallel effective nikalo. So 12 into 20, this is 515 plus 5. So 12 into 20 by 12 plus 20 gives you 240 by 32. Now what is the total resistance? 1 ohm plus 240 by 32 plus 1.5 ohm. 1 ohm plus total effective is 240 by 32 from this bridge network, because you have removed this R due to balancing conditions. 1 ohm plus 240 by 32 plus 1.5 ohm. This gives you 32 LCM, and then you have a 32, 240 and 48. This is 268. 32 gives you 320 by 32. 10 ohm is the answer. So the option is B. 10 ohm is the answer. Next. Are you all hearing?
Yes, ma'am.
Yes, please.
Yes, ma'am.
Which slide I was in? I was here, no? Right. Not responding. Phone Yes, 1 minute, please. Let me go to the slide. Let me go to the slide. Here we had a problem, no? Loop by. This part I have explained. This I have explained. We have explained all this. We have gone through this 10 ohm. Okay. Now this one. In the given circuit, R1, just can you see the circuit? Yes. Can you see the circuit, please?
Yes, ma'am. Yes, ma'am.
Okay. In the given circuit, R1 is 20 ohm, R2 is 8 ohm, and E is 15 volt. This is 15 volt. R1 value is 20 and R2 values are all 8. R2s are all in between. Just see, R2s are all in between, and in the straight you have R1, 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 4 R1s. In the down below also you have 4 R1s. And the value of the E is maximum potential is 15 volt. Then the effective resistance of the circuit is calculate. Now you check from this point to this point. What is this circuit which I have dotted? I have made a closed figure. R1, 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 and in between you have R2. Again, you apply the Wheatstone bridge condition balancing conditions. You'll see that the potential at this end of R2 and this end of R2 is 0 because R1 square is equal to R1 square. Okay, PR is equal to QS. That is satisfied. So you can say you can remove this R2. Similarly, you can make another circuit here and remove the second R2. Similarly, you can make another circuit and remove this R2. So all these R2s can be removed and you will finally get this kind of a circuit. You will finally get R1, 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 R1 in parallel to the next rows R1, 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 R1. So the effective resistance will be 4 R1s in parallel to 4 R1s. These are series combinations. So effective is 4 R1 here in parallel to another 4 R1 effective. So what will be the net equivalent? 4 R1 into 4 R1 by 8 R1. So you will get 2 R1. And what is the value of R1? Is 20. So 20 into 2 is 40 ohm. So the answer is 40 ohm. So the option, whichever option is 40 ohm, just tick that. Next. In the Wheatstone bridge, I hope you understand, you have a P, you have 2 ratio arms, and you have a battery circuit and you have a galvanometer circuit. P by Q is R by S. P and Q you can have nearly equal resistances, and R is LR by 100 minus LR, resistivity. Resistivity gets cancelled. So you can say that Wheatstone, you have a battery in one circuit and you have a Wheatstone bridge, you have a galvanometer in the other circuit. Now question is, in a Wheatstone bridge, if the battery and the galvanometer are interchanged, then the deflection in the galvanometer will change in the previous direction, will not change in opposite direction, none of this. It will not change because you are making AC as BD and BD as AC. P by Q is R by S can also be changed as P by, you can say R by S is equal to P by Q. So you can make any one P and Q. You can interchange. Okay, so that will not give any difference because there'll be no current at the two end jockey, the point jockey, the B and D's across, the potential is same. So it will not change. Now this is another one corresponding to meter bridge. When a metal conductor is connected to the left gap of a meter bridge, you know, in the meter bridge you have a known 2 ohm resistor and an unknown, and then you have the jockey to be connected, LR and 100 minus LR, that is the meter bridge. So metal conductor connected, when a metal conductor is connected to the left gap of the meter bridge, which is heated, what happens to the balancing point? You know, in heating what happens? Length changes, the resistance increases. So what will happen? The length will increase. So it will shift towards right. It will shift towards right. It's very easy.
Right.
The next one. Determine the impedance. Suppose it is written impedance. You must tell the students that impedance is also load. Okay. Load in the following circuit. Determine V by I. That means in the following circuit. What is the circuit? The circuit I have already remade because I had to save time. But the circuit had only this V, 4 ohm and this figure. They did not have this ground. I made it. I made that this should be 0, 0, 0. What is the symbol? plus minus. This is called a voltage source. But outside is the kya likha hai in the circuit? It is written already 2I. So this is current dependent voltage source. This is a current dependent voltage source. 2 volt is here from 0 to 2I. That means in this node, if I say this is 0, I plus law, please understand that this nodal is maximum voltage. This is greater than this one. So V minus d by 4 will be here, the current here. And what is the current here going? You can see that this is 2I volt and this at this node the current, Kirchhoff's current law, I1 is going like this towards your left. This is going towards your right, I3 towards right. It's I. So I2 and 3 are going I2 plus I0. Now see, what is the I1 signature sign? What is the sign of this I1? Negative. So I1, if you have the voltage, then this will minus I. So it will be minus I. It is going in the direction. Now what will be the current through this one? I2. What will be the current? I2. This will be voltage V minus 0 because this is 0. Here upper node mein voltage hai V minus 0 divided by 4 ohm. So this I will be V minus 0. Then I3 is V minus 2I. The nodal voltage here 2I. V minus 2. What is the resistance here? 2 ohm. So V minus 2I by 2 ohm is I3. Do you get it? V minus 2I by 2 ohm is I0 by 4 is I2. And already there minus I. So you can say that to take the LCM minus I. This is your V. This is 2V minus 4I. This get minus V equal to 0. So V by I is equal to 8 by 3 and that is your impedance. They have asked to calculate the impedance of the load in the circuit. 4 by 3, 8 by 3, 4 and 2. So option 2 is correct. Next, determine, there is a circuit. Determine I1 in the following circuit. Before I explain this question, this solution for this, the options are 4 ampere, 2 ampere, 4.76 and 10 ampere. Now you have, this is, if a symbol is there, this is a current source. Current source and bahar kya likha hai? No voltage. This is 5I1. This is current dependent current source. If it was 5 volt, it would have been voltage dependent current source. Here it is 5I1. So this is current dependent current source. You have two dependent sources. One is current dependent source, one is a voltage dependent source. You have current dependent current source and voltage source. You have voltage dependent current source and voltage source. In our case, it is current dependent current source and the symbol is a arrow mark. But if you had a plus minus, it would have been a voltage source. Okay, here it is a symbol, so it is a current source. If it was a plus minus, it would have become a voltage source. Here it is ours. Ours is a current source. This is a voltage source. 250 volt jahan likha hai. Now, in this case, you have again apply the load at the node I1, I2, and I3 is 0. Now, in the diagram, it is written 5I1 is going towards the node. 5I1 is going towards the node. Now, here, this direction, I1 is coming towards the node. I1 is coming and 5I1 is going towards the node. So what will be the Kirchhoff's current law says? What will be the current in this 10 ohm resistor? 6 ohm, 6I1. I1 going like this, 5I1 is coming through this. So 5I1 plus 5I1. So this will be 6I1. So Kirchhoff's current conservation of charge. So this will be 6I1. Is it clear? This is plus I1 towards the node. This is the node here. And 5I1 is coming towards this node from the current source. And then what will be towards the 10 ohm? The 6I1. Okay. So I1 is going. 5I1 is also coming towards and 6I1 is going away from the node. So 6I1. Let us apply KVL. See the diagram in the arrow KVL. So I am taking only this circuit. 250 volt, 2.5 ohm voltage and 10 ohm voltage. Let us see this. 250 volt is positive. So first is the 250 volt. Then what is in the last, in the element of the resistor 2.5, last is minus. So you will write minus here. Minus, what is the voltage? Voltage is current I1 into 2.5 ohm. This is important, students. This minus sign you gather from here because it's minus here. So minus I1 into 2.5. Next, it is coming here. The last bit is minus again. Put a minus here into 6I1 multiplied by 10. 6I1 multiplied by 10. That will give you the voltage. So this will be 60I1 with a minus sign. This will be minus 2.5I1 with a minus sign. And this is 250 volt. I repeat, 250 minus 2.5I1 minus 60I1 is equal to 0. Or 62.5I1 is 250. Divide 250 by 62.5. What do you get? I1 as 4 ampere. I1 as 4 ampere. So the option 1 is correct. Okay. Next is, again, there is a 30, this is a voltage, there are 3 sources. This is a voltage source. This is also a voltage source. 36 volt plus minus sign is there. Here also plus minus sign. 30 volt, 30 volt. Make it grounded here, 0 volt, 0 volt. This is 0 volt. So this becomes 36 volt. Here up here it becomes 30 volt. So here it is 30, here it is 36. Okay. Then here it is 0. This is nodal voltage V, which is the maximum voltage. Remember this. This has to be V minus 30. Here it should be V minus 36 when you are calculating in your directions. Now see this. I1, I2 and I3. Apply KCL at the node N. I1 plus I2 plus I3 is 0. Now note the voltage is always higher than the nodal voltage is higher than the other voltages like 30 and 36. So what is your I1? I1 current, please check V minus 30. V is the nodal voltage minus 30 volt divided by the resistance kitna hai? 10 ohm. So I1 is V minus 30 by 10. So I1 ke jagah likho V minus 30 by 10. What is your I2? I2 is a current source, you know. It is a, so I2 9 ampere likha hai. So it will be 9 ampere, but it will be minus because it is going in this direction. So it will be inward, so minus 9. V minus 30 by 10. Then I2 is 9 ampere written. We are not calculating. Minus 9 you have to write. Sign has to be minus. Then go to the I3 part. I3, 36 volt. Here nodal voltage is maximum. So V minus 36 divided by this resistor 20 ohm. V minus 36 by 20. This is plus. So if you calculate this, L is 20. 2V minus 60 minus 180 plus V minus 36. 180 and 36 and 60. Add them together, it becomes 276 with a minus sign. So 3 volt is 276, 1 volt, V is 92 volt. So option 4 is correct. The other part I leave it to you, it is very easy. Just look at the circuit. Determine the ratio in the circuit. I1 is to I2 is to I3. This is no bridge circuit, nothing, because it has only 3 resistors. There is an EMF. All are parallel. So EMF across 2R is same. EMF across 4R equal to EMF across 6R. So EMF is current across R is same in all directions. Look at this. E is same. So what is the current? Current I1 is what? First find out I1. I1 is E by 2. I2 is E for R. I3 is E by 6R. Why E by? Why E by? Because they are all parallel connected. So E is the voltage. So E is, if you take it off, you'll get 1 by 2 is to 1 by 4 is to 1 by 6. 12 is the LCM, so you get 6 is to 3 is to 2. So this is the option 3 will be correct. The last part, determine the value of the resistance in the circuit. Again, here 0, this is 50 volt. Not done. This is all are grounded. I have made it again. If this is not given, you have to ground this one. Make the nodal point V. This is the voltage maximum. This is 0 volt. This is V volt. Here it is 50 volt. Here it is 0 and this is 4 ampere coming inside R. You have to calculate the value of R. Okay. Now let us apply KCL at the node where it is V written. I1 plus I2 plus I3 equal to 0. What is I1 at the node? What is I1 at the node? V, you know, nodal voltage is maximum. V minus, you will have minus 50 volt divided by the 6 ohm resistor. So V minus 50 by 6 is I1. What is I2 going? I2 is how much? V minus 0. This is V minus 0 by 7 ohm. I2 is V minus 0 by 7. What is I3? Written already 4 ampere. So 4 ampere. Sign is positive. So V minus 50 by 6 plus V minus 0 by 7 plus 4. LCM 2 into 4 gives you 88. No, 168. 168 This part will be 7V minus 350. This will be 6V. 7V, 6V, 13V. 13V minus 350 plus 168 is equal to 0. So 13V is equal to 350 minus 168. What do you get? 182. So V becomes 14 volt. Now you know 14 volt across this. V equal to 14 volt here. Now, if it is 14 volt, current is 4 ampere. So 14 by 4 ampere is 3.5. So the option 1 is correct. Option 1 is correct. So this is the next. So the last of it is this one. Find the voltage of resistance. I will finish it. Find the voltage across AB. Now, you know, this is like a bridge network. Now you are bringing current I, and you are sending through this branch I1, and then across 20 ohm, you are sending I2. I2 jara either I2 through the 10 ohm and then coming to B. This I1 is going through the 30 ohm and 15 ohm and coming to B. So now look at this. Now 20 into 15 is 300, 30 into 10 is 300. Tell your children that it is P, that is PR is equal to QS. So you can remove this 50 ohm. So you can bridge is balanced. So you can say that there'll be remove the 50 ohm, and then you can say potential across these two ends are the same. Difference is 0. So 30 ohms, then what are the two things that will be in here combined in series? 20 plus here, you can say 30 and 15 will be in series, and it will be parallel to 20 and 10. So you will have 45 ohm, that is 30 plus 15, 45 ohm parallel to 20 and 10. Why? Because you have removed this 50. This 50 is gone. So here joined, here and here 30 and 15 are joined. 45, okay, 45 plus 30. That is R1, R2 by R1 plus R2. What does this give? This is 1/3. This is, I have shown you here. 45 ohm parallel to 30. Answer is 18. So option 1 is correct. Okay. Similarly, this one, you have a 24 volt. There is a current 1 ohm. This is a current 1 ohm plus minus. This is given. 2 VV is given, and there is 1 VV given. I is moving, and this circuit is given like this. This is 4 ohm minus plus is given. These all signs are given in the circuit. Now see this, we can solve it using KVL. 24. Now idhar jao, minus hai. So minus current I multiply by 1 ohm, minus laga. Then either 2V ka plus laga, because the last one is plus sign. Then come to this one, this is minus hai either. Then you have 2V and minus VB. Then you come to this one, here again minus laga hai, minus 4I. This is equal to 0. But what is VB? VB is I into 3 ohm. So VB is 3I. Just see, substitute VB as 3I in our equation. Just see, 3 ohm into I is VB. So substitute in our this equation, VB equal to 3I. Substituting this, 24 minus I plus 2 into VB is 3I. This is 6I. Again, VB is 3I, minus 3I and minus 4I. This gives you 2I is 24, I is 12 ampere. So the option 1 is correct. I wind up with this. And there are only 2 more. This part is, all of you know that galvanometer is a null deflection. So this is option D. The false statement is Wheatstone bridge is susceptible to high DC current is a false statement. And the next one is, which one is a detecting point in a Wheatstone bridge? That is galvanometer. All of you are teachers. I think you know the option C is correct. So thank you. Any difficulty, let them share it with me in WhatsApp.
Yes, now I request all the PGTs that if you have got any difficulty, you can share up with madam in the WhatsApp. You can share up. Okay, before we
Hello.
close, I remember go back to 2 years back, that when she was the coordinator for Olympiad in physics in Eastern India, and I was the coordinator for Olympiad in Eastern India in biology. Now, that reminds me of our old days at BJP College, and both of us are, and when both of us are working, and when both of us are working,
today you'll get it. All those people are, it is coming to my mail also. Sure. Who is this person?
Hello.
Yes.
Hello.
I'll be sending it shortly. Okay. Definitely today.
One question was sent.
No, not on this one.
3 or 4 questions. Madam will send the answer in the WhatsApp. She will share it. Now it reminds
sir.
me of last 20 to 25 years when
The time I have taken
everything
long
becomes
time.
very fresh.
Sir, I have
Anyway,
taken-
thank you very much. You have learnt a lot because you know that the new pattern of examination is mostly MCQ type, and in future days we will also like to share with Madam for your as well as for the PGTs of HSS or the higher secondary schools.
There are three.
Thank you
so
very much.
Five of them have given.
Yes. So 5 questions have been given, and Madam will address those questions in the WhatsApp little later because we are going to
Sir,
close the
hello.
session now. Yes, yes, Madam, you want to speak something? Please speak. Anybody? No, you
hello.
can say. हाँ,
बोलो।
बोलो क्या बोलना चाहते हो?
Sir, actually, ma'am, in which WhatsApp group we will send the questions, our doubts, ma'am?
Which?
You have a group.
Which what?
You have a group now. What's EMRS?
In that
EMRS WhatsApp.
in that PG,
You have,
Mishra,
listen,
In the
look, my mail is mishra.arundhati60@gmail.
yes.
okay, ma'am. Okay, ma'am. Thank you, ma'am. Thank
Thank
you.
you, and you can have the EMRS physics WhatsApp group also that you can send.
Sir, I'll send it.
Yes. So thank you very much.
Can you share your mails?
WhatsApp to the
Ma'am, me, ma'am.
Yeah.
Please tell me your mail ID.
Subrajit,
Subrajit,
P4.
just send it through the chat. Send it to the chat,
Send
please.
it to the chat or in the WhatsApp group.
No, WhatsApp नहीं chat में बोल
Okay,
दो.
okay.
Chat में बोल दो. What
Okay,
is
ma'am.
your-
Okay, ma'am. Let me to send.
Yes. you can.
Send कर दो chat में.
Okay. Thank you very much. And we are going to close this session for today. And the next after 7 or 8 days, on the third session.
12 of them.
Another paper.
Actually, ma'am. Excuse me, ma'am.
Yes, please.
Ma'am, actually, I do have some other doubts also. So can I send it in your Gmail ID?
Sure.
Okay.
Just take it all small. Mishra, MISHRA Mishra dot Arundhati ARUNDHATI 60@gmail. Okay.
Another paper.
Yes, ma'am.
Thank you.
Let
You
me
send
type
all
it.
the
Okay,
there.
okay,
It'll
okay.
be easier for me to interact.
Yes,
The
yes.
time is
yes,
short,
ma'am.
children.
Okay.
I'm very sorry. I have taken more time. I have taken more time than
No, ma'am. No
necessary.
issue. No. No issue, ma'am. No issue, ma'am.
Thank you for a patient hearing. I didn't have a pointer here. The pointer was moving
Yes,
away.
ma'am. Thank you. Yes,
Thank you, students.
ma'am.
Okay, thank you.